In the first minutes before dawn, when the sky is still an unbroken bruise and the observatories are nothing more than silhouettes against frozen mountain air, a pattern began to appear in the deep field images that should not have been there at all. It was not a flash, not a burst, not the theatrical violence that usually announces itself across the cosmos. It was subtler than that, and in some ways far more unsettling. A faint structural absence, a region where the expected distribution of distant light bent, thinned, and gathered around an invisible center, as if the universe had exhaled and forgotten to draw breath back in. If you're drawn to mysteries like this, there's always more waiting for you here, beyond the universe. At first, the researchers thought they were looking at an instrument artifact, a ghost in the calibration, a flaw in the mosaic of long-exposure imaging. But the anomaly remained after the data were reprocessed, after the filters were changed, after every ordinary explanation had been pressed, folded, and set on fire by the numbers themselves. What they found was not a mistake. It was a silence in the architecture of space, a place where the familiar logic of matter and gravity seemed to loosen its grip. If you want to keep looking into the darkness with us, subscribe to Beyond the Universe. The image came from a survey so deep it felt less like looking outward and more like falling. For months, the telescope had held still on a single region of darkness so small it could be covered by a grain of salt at arm's length, and yet within that negligible patch, it gathered enough ancient light to map galaxies whose photons had been traveling since the universe was young enough to still be learning how to stretch. The result was a crowded, glittering ruin of distance, amber points, smeared arcs, spectral traces of worlds that had already changed into something else by the time their light arrived. But among that crowded testimony, one region seemed wrong. It contained fewer structures than probability allowed, fewer galaxies than the underlying distribution should have produced, and the emptiness was not clean. It was shaped, it leaned, it behaved like a wound that had not quite finished closing. The first response was caution, then skepticism, then the familiar procedural patience of science. Data were cross-checked against another instrument, then another. Redshifts were verified, background noise was modeled, atmospheric distortions were removed from the ground-based follow-up. Space-based readings were compared with independent surveys spanning infrared, optical, and microwave bands. Every step should have restored confidence. Instead, each new layer revealed the same unsettling outline, as if the void had been waiting beneath all the corrections, beneath all the carefully built scaffolding of certainty. There are moments in discovery when the universe appears not as a machine, but as a listener. It feels in those moments as though the cosmos has become aware of being observed and has chosen to answer by becoming more difficult to read. At first, the void seemed like a triumph of interpretation rather than a threat to it. Cosmology has always contained emptiness. Most of what the universe is in the ordinary language of matter is not matter at all. Space is wide with intervals, and even the brightest galaxy hangs inside a vastness far more severe than its own light can conquer. Yet this particular region carried a different kind of emptiness. It was not simply underpopulated, it was dynamically unusual. Nearby galaxies appeared to drift away from it in a pattern that suggested a gravitational landscape, too smooth, too exact, as if the local web of cosmic structure had been tugged loose from something beneath it. And this led to something more disturbing. If the void was not just a gap, but an imprint, then something had to have shaped it. The shape of the unseen mattered more than its darkness. Dark matter, that patient and invisible majority, was the first suspect. It leaves no light of its own, but it reveals itself in the way galaxies rotate too quickly, in the way clusters bend the paths of distant photons, in the way structure appears at scales too large to be accounted for by luminous matter alone. Perhaps, the scientists reasoned, the void was not empty but overfilled with some arrangement of mass that did not interact in the normal way. Perhaps a massive halo of dark matter had carved the neighborhood into a contour too subtle for ordinary eyes, redirecting galaxies into long filaments around a hidden center. It was a beautiful explanation. It was also unstable from the beginning, but that explanation created another contradiction. Dark matter, for all its invisibility, still behaves like mass. It makes the universe heavier, not stranger. It pulls, it clusters, it participates in the slow sculpting of cosmic structure. Yet the void did not behave like something merely pulled apart by gravity. It behaved like a pocket of altered expectation, a place where the absence itself was active. The stars around it were not simply fleeing from a hidden concentration of mass. Some seemed misaligned, as if the geometry of their surroundings had changed. Lensing arcs in the infrared bent with a curvature that did not fit the visible distribution. The calculations were repeated so often they began to feel like rituals, and still the same result returned. The invisible did not account for the shape of the unseen. In the control rooms, under the cool glow of screens that flattened the night into digits, the astronomers moved from possibility to discomfort. One of them described the phenomenon as a local underdensity, a region where the cosmic web had simply failed to assemble, but even that language failed to capture the feeling of it. A true underdensity is a failure of abundance. This was different. It suggested not merely that matter was missing, but that the universe had organized itself around a subtraction. The void was not the absence of a thing, it was the presence of a condition. You begin to realize that these distinctions matter. In the history of science, the edge of understanding is often found not where something appears, but where a category breaks down and refuses to stay still. The deeper they looked, the more the void seemed to resist being isolated as a single anomaly. It connected to larger patterns in the cosmic background, those ancient fluctuations etched into the afterglow of the universe itself. On the map of the microwave sky there were alignments, subtle cold regions, gentle temperature asymmetries, ripples that should have averaged out into statistical humility, but instead accumulated into a quiet unease. The void appeared to correspond, however imperfectly, with a larger directional tension in the data, as if the emptiness was not local at all, but part of a broader unevenness in the universe's deep structure. This was where the atmosphere in the room changed, not because anyone had found a breakthrough, but because the boundary between one problem and another had begun to dissolve. A universe that is uniform on large scales is the foundation of nearly everything we think we know. It permits the equations to remain elegant. It allows the distances between galaxies to be compared without surrendering to chaos. It makes the cosmos legible. But if legibility begins to fail in one region, then the assumption of uniformity is no longer a background condition. It becomes a question. And once the question is asked, it spreads. The void forced the researchers to revisit the principle that the universe, beyond a certain scale, should look the same in every direction. It should not prefer one region over another. It should not lean. It should not hide sharp irregularity inside a field otherwise built of balance. But the data suggested a preference, a bias, a cosmic asymmetry that could not easily be dismissed. A few nights later, infrared observations added a new layer of unease. In that band, where warm dust glows faintly and distant galaxies emerge as subdued smudges against deep black, the void's boundary looked more articulated than before. There were filamentary edges, almost like tendons, stretching around the dark region. Some galaxies appeared reddened in ways that did not fit their estimated distance. Others displayed odd motion relative to the background expansion. What was supposed to be a simple accounting of faraway light now contained signs of stress in the fabric itself. The models that had once separated mass, motion, and expansion into elegant components began to overlap like transparent sheets, misaligned by a fraction of a degree, and in the overlap, something moved. The human instinct at such moments is to search for a familiar cause, a hidden cluster, a foreground lens, a calibration bias, a statistical fluke born from the terrible patience of large numbers. It is a noble instinct. It has rescued science countless times from premature wonder. But it gets worse when each rescue attempt deepens the original wound. Every conventional explanation demanded another correction, and each correction made the structure more precise, not less. If the void was an artifact, it was the most disciplined artifact ever recorded. If it was a coincidence, it was a coincidence with geometry. If it was noise, then noise had begun to display a memory. There is a particular kind of dread that enters only after the first layer of disbelief has been peeled away. It does not arrive with thunder. It arrives with repetition. A result that should have vanished returns in a new dataset. A new algorithm confirms it. A different observatory sees the same contour from another angle. A skeptical collaborator in another hemisphere, working with a separate reduction pipeline, sends a message in the middle of the night. The pattern is still there. It was never dramatic enough to be frightening in a conventional sense. That was the problem. It was patient. It was quiet. It had the texture of reality. So the investigation widened. A void alone could be explained as an accident of structure formation, a rare but acceptable cosmic scar. But the region surrounding it contained a web of behavior that was beginning to sound like a message written in the language of absence. The galaxies nearest the boundary did not just cluster irregularly. Their motions hinted at a bulk flow that might extend beyond the region itself. If true, matter in the local universe was drifting in a direction that could not be traced to the usual nearby sources. Something far away, or something deeply embedded, was nudging the flow. In the equations, the possibilities multiplied. A supervoid, a misestimated density field, a relic from the early universe, an interaction with dark energy on local scales. But each hypothesis, when stretched to fit the data, became strained enough to fray. Dark energy entered the discussion with the kind of reluctant authority that only comes from not being understood. It is the name given to the accelerating expansion that seems to define the large-scale fate of the cosmos. It is not a thing in the ordinary sense, not a particle in a tray, not a cloud one can isolate, not a field whose behavior has been tamed by familiarity. It is the pressure of the universe against itself, the broadening between galaxies that grows more dominant as space expands. If the void was unusually large, perhaps dark energy had shaped it more aggressively than expected. Perhaps space-time itself had thinned there, not by missing matter, but by an excess of cosmic push. Yet this raised a colder possibility. If the expansion was locally uneven, then the universe might not be governed by a smooth global rule after all. It might be variable in ways we have not learned to admit. That possibility altered the mood of the work. The void was no longer merely a region to be measured. It became an interrogation of assumptions. Expansion, in the standard picture, is not a wind blowing through space, but the stretching of space itself. Distances grow because the metric grows. Galaxies recede not because they flee through a void, but because the stage beneath them changes shape. To suggest that this behavior could vary with locality is to suggest that the stage is not as stable as we thought. And suddenly the researchers were no longer asking why one region of the sky looked strange. They were asking whether the universe's most basic motion might be less consistent than the mathematics had promised. You are looking at a cosmos that seems to obey rules only while it is being averaged from far enough away. Up close, the logic thins. The observations in that sector of sky formed a corridor of uncertainty, leading back not to a single object, but to the machinery of measurement itself. If one patch of universe could distort the inference of the next, if distant photons were being bent by structures too irregular to fit the map, then every conclusion became provisional. The team started to speak in the language of confidence intervals and systematic uncertainty, but underneath the terminology was a more primitive sensation, the fear that the universe may not be simply unknown, but actively underdetermined by the methods we use to know it. The void drew attention from other disciplines. Statistical cosmologists joined the analysis, searching for selection bias. Computational modelers ran synthetic universes under various initial conditions. Observers with access to different wavelengths tested whether the effect persisted in radio catalogs and X-ray surveys. It did. The void remained. But what changed, and what became much more troubling, was the behavior of the surrounding structures in those simulations. When the observed anomaly was inserted as a boundary condition, small variations cascaded outward, filaments snapped into alternate alignments. The large-scale distribution of matter became unusually sensitive to minute adjustments. This sensitivity should have been dampened by cosmic history. Instead, it seemed amplified, as though the region sat near a threshold where the universe's usual statistical calm had been replaced by something brittle. There are places in nature where a small push triggers a much larger transformation, a snowfield under tension, a crust of ice, a mountain slope loaded with weight. Astronomers know this language well because the universe is full of thresholds disguised as distances. But here the metaphor failed to comfort. The void did not behave like a landscape nearing collapse. It behaved like a question of rules. What if the distribution of matter on the grandest scales is not merely random, but only apparently random, the visible trace of an underlying process that we cannot yet see, because the process itself does not remain still long enough to measure? That thought should have stayed abstract. Instead, it found a home in the data. The first sign that the anomaly might be more than a void came from a set of spectral distortions in light passing near its edge. The effect was subtle enough that a less obsessive team might have dismissed it, but the shifts in wavelength did not correspond neatly to velocity alone. Some features hinted at unusual gravitational gradients. Others suggested lensing by matter that was either unusually diffuse or arranged in a topology the current models had not anticipated. The team checked whether an unrecognized foreground object could be responsible. Nothing. They checked for a hidden cluster cataloged incorrectly. Nothing. They checked whether relativistic corrections had been mishandled in the pipeline. Nothing. Every corridor led back to the same dark chamber. The sky itself was not behaving as the equations expected. That is when the language in the room changed from uncertainty to unease. Not because the scientists had become less rigorous, but because rigor had begun to produce results that felt impossible to place within any one framework. A model is supposed to be a bridge between what is seen and what is inferred, but when the bridge leads to a cliff, The issue is no longer whether the river below is deep. The issue is whether the far shore exists in the way we think it does. The void appeared to be a subtraction in the structure of the cosmos, but the more carefully it was studied, the more it suggested an addition, a hidden variable, a missing law, a layer of behavior that current physics had not yet learned to count. There was a night when the lead analyst stayed after everyone else had left, staring at the stitched composite image from the deepest infrared field. The room was dark, except for the monitor's pale spill across notebooks and empty coffee cups. The image looked like a field of embers suspended in tar, with one region that seemed to draw the eye, not because it glowed, but because it refused to. Around it, galaxies arranged themselves in filigree strands. Farther out, the density of points rose again. The void sat there like a held breath, and in the center of that absence, the analyst noticed something that had not been visible before. A faint symmetry, too deliberate to ignore, as though the boundary itself had been curved by an intention too remote to recognize. It is difficult to describe the emotional shift that occurs when a pattern begins to seem purposeful. Scientists resist that impulse for good reason. Purpose is cheap. It can be projected onto anything. But the universe sometimes appears to invite projection by behaving with such eerie coherence that the mind reaches for language it knows it should distrust. No one in the room said, "design." No one needed to. The danger was not that they believed the void was intentional. The danger was that the data no longer behaved within the assumptions the models were built to preserve. Once that threshold is crossed, objectivity does not disappear. It trembles. They returned again to the notion of entropy, that great measure of unfolding disorder toward which the universe seems to drift. On the scale of stars and galaxies, entropy is not merely decay, it is direction. It is the reason heat disperses, why structures burn fuel and eventually exhaust it, why the cosmos seems to be moving toward a future in which energy is spread too thin to do useful work. But here the void introduced a complication. If the surrounding structure was unusually ordered in its absence, if mass had been organized so selectively around it, could that be an expression of entropy's long arc, or something interrupting it? The question had no comfortable answer, because the deeper they looked, the more it seemed that the universe was not simply aging, it was arranging its aging in patterns they had not anticipated. A few theorists proposed that the anomaly might be connected to the early universe, to primordial fluctuations magnified by inflation and preserved as scars across cosmic time. That explanation sounded promising until it was examined in detail. Inflation can amplify tiny differences into enormous structures, yes, but it should do so statistically, without local preference beyond the constraints of the initial field. Yet the void and its surrounding asymmetries appeared too distinct, too coherent, like an event that had left a memory instead of a distribution. Another group suggested a collision with an unseen domain in the infant cosmos, a bruise from a region of space-time whose physics had differed just enough to alter the local terrain. And what scientists realized next was even more unsettling. If one collision could leave such a mark, then the universe might be littered with scars we have mistaken for ordinary structure. For every explanation that promised relief, another contradiction waited beneath it. A primordial scar implies the universe has a history more fragmented than our models admit. A dark matter arrangement implies invisible mass can shape not only motion, but the apparent geometry of emptiness. A dark energy irregularity implies the expansion of space may not be uniform after all. A measurement error implies our instruments are not merely limited, but fragile enough to mimic new physics. But what if the error is in the assumptions behind the instruments? What if the categories used to define the observations are too small for what is actually there? The questions were no longer confined to one void. They were rising, slowly, into the framework that made voids meaningful. In the weeks that followed, the telescope time expanded. Other targets were added, other deep fields were compared, and elsewhere in the data, in places that had once seemed unrelated, similar tensions began to show themselves. A region of unexpected thinness in galaxy counts. A lensing pattern that bowed in a direction inconsistent with visible mass. An infrared field, where distant structures appeared arranged around a depression in the background density. Individually, each anomaly could be explained away. Together, they began to look like fragments of a larger instability, not a singular event, but a family resemblance. The cosmos was not presenting one impossible object, it was presenting a style of impossibility. That phrase traveled quickly through the collaboration because nobody liked it. Style implies repetition. It implies that the universe may have preferences. If the anomalies shared a style, then they could no longer be treated as isolated failures of interpretation. They might instead be expressions of the same hidden mechanism playing out in different regions and different wavelengths, a mechanism operating beneath the surface of what current cosmology can confidently parameterize. The lead theorist, who had spent a career defending the standard model of cosmic evolution, was heard in the hallway saying something so quiet that it nearly vanished under the air vent. If the universe has a style, then we may be looking at its handwriting. That sentence haunted the team, not because it was poetic, but because it revealed how quickly wonder can turn into suspicion. Handwriting implies authorship, yet the data offered no author, only arrangement. Still, the metaphor persisted because it captured a terrible intuition. The universe might behave less like a stable structure and more like a dynamic system whose large-scale behavior changes across conditions and scale. And if that is true, then scientific certainty is not merely difficult. It is conditional on the behavior of something larger than the observer's framework. The instruments can record, the models can infer. But what if the thing being studied is capable of changing the terms of being studied? Observational astronomy has always depended on time. We do not visit distant galaxies. We receive their past. We do not inspect cosmic structures directly. We read the delayed testimony of light. That delay is part of the grandeur of the field, and also its vulnerability. Every image is an archive of loss. Every spectrum is a fossil of arrival. The further out the eyes go, the more the universe becomes a record of conditions that no longer exist in the form we are seeing. This has never been a problem before, because the laws were assumed to be constant enough that the past could stand in for the present. But if the anomaly reflects a deeper instability, if the universe changes not only over time but in the rules by which time is interpreted, then our entire observational foundation begins to sway. The team started to compare the void against numerical simulations of large-scale structure formation, pushing the initial parameters into increasingly extreme ranges. As the models thickened with complexity, some of them generated enormous cavities, but none reproduced the precise combination of density deficit, boundary sharpness, lensing irregularity, and motion bias observed in the real data. One simulation came close enough to provoke excitement, then failed at the last stage by producing a surrounding cluster where none existed. Another generated the right void size, but only by introducing an early universe fluctuation so improbable, it collapsed the credibility of the setup. The problem was no longer that no model fit. The problem was that each model, to fit one part, had to violate another. That is the kind of failure that feels personal after a while. Equations are supposed to resist emotion, but humans are the ones holding them. And humans notice when reality appears to reject every attempt at simplification. A lesser mystery could have been solved by better data. This one seemed to improve when challenged. More precision sharpened the contradiction. Higher resolution revealed finer inconsistencies. Longer integrations did not settle the issue. They enriched the architecture of doubt. It was like staring into a wall of dark glass and discovering, after enough time, that the reflection is not of the room you are standing in, but of something behind you that does not move the way it should. The first public presentation of the anomaly was restrained to the point of embarrassment. The researchers used careful language, every sentence dressed in the caution of professionals who know how history punishes overstatement. They spoke of a statistically significant irregularity. They mentioned possible local underdensity. They admitted the need for further analysis. Yet the room was tense because everyone present understood what the slides did not say. There was an edge to the finding. An implication that the cosmos might contain structures whose existence was not just unknown, but algorithmically resistant to the assumptions that made the search possible. At the end of the presentation, nobody applauded immediately. The silence that followed had the heavy texture of something too large to fit comfortably into words. Outside the conference hall, the night was clear enough to show a sky scattered with ordinary stars, each one a point of delayed fire against the black. The irony was almost cruel. The universe above them looked serene, continuous, almost indifferent, but below that appearance lay the staggering possibility that the sky's apparent coherence was only a surface effect, a visual comfort, masking deeper irregularity. It is one thing to know intellectually that the cosmos is vast and empty. It is another to feel, with the soft dread of standing at the edge of a cliff, that the very order by which vastness is measured may not be as secure as we thought. The stars remained, the silence remained, but the meaning of both had begun to shift. There was no dramatic warning, no signal from the heavens, no cinematic rupture in the night. The unease built the way frost spreads across glass, slowly, internally, with a beauty that does not lessen its threat. Across the collaboration, Researchers who had once spoken confidently about sampling variance now found themselves asking whether the anomaly was local, global, or conceptual. A local problem can be mapped. A global one can be modeled. A conceptual one changes the rules of mapping and modeling at once. That was the hidden terror inside the void. It had moved from object to ontology. It was no longer only a patch of missing structure. It had become a test of whether the universe, when probed deeply enough, reveals itself as coherent at all. And so they pushed further, because science has no other honest direction to go when it meets a wall. They examined gravitational wave backgrounds for subtle correlations. They checked whether peculiar velocities of nearby galaxy groups hinted at a basin of attraction beyond the visible survey volume. They questioned the calibration of distance ladders and the assumptions embedded in standard candles. They revisited the Hubble tension, that persistent mismatch between measurements of cosmic expansion inferred from the early universe and those derived from the nearby one. Usually, the Hubble tension feels like a technical dispute. In the shadow of the void, it began to feel like a crack in the floor. If the universe is expanding at different rates depending on how and where we measure it, then the cosmos may not be as globally smooth as we hoped. If the early and late universe refuse to reconcile cleanly, then perhaps our stitching of epochs is flawed. If dark energy evolves rather than remains fixed, then the future of all structure becomes uncertain in a new and more intimate way. The calculations surrounding the void touched every one of these nerves. It was as though the anomaly had pressed a finger against the larger body of cosmology, revealing places where the system was more vulnerable than it appeared. And the more pressure they applied, the more the response suggested not failure alone, but hidden complexity. Somewhere in the middle of this, one of the younger researchers asked a question nobody had wanted to ask aloud. What if the void is not an absence in the universe, but an absence in us? The room fell still. It was not a philosophical flourish. It was a concern born of the work itself. What if what appears as missing matter, unexpected expansion, or irregular structure is really the product of an incomplete perceptual language? What if the instruments, however exquisite, are tuned to only one mode of reality? If so, then the anomaly is not a broken patch in the cosmos. It is a boundary marker for the edge of human comprehension. The thought was too large to reject quickly. It sat there, cold and luminous, refusing to go away. By then, the void had become more than the site of a discovery. It was a pressure point where every comforting assumption about the universe's transparency began to crack. Deep space imaging showed it. Infrared surveys hinted at it. Background radiation patterns reflected it. The motions of nearby structures complicated it. Simulations failed to contain it. Each line of evidence pointed outward and inward at once, as if the cosmos had arranged a riddle not to conceal a single answer, but to expose the instability of asking. Because the deeper they looked, the more the universe seemed to insist on being greater than its description, and that, more than the void itself, was what unsettled them. There is a threshold in every great scientific mystery where the object of study starts to dissolve into the conditions of observation. In the beginning, the researchers believed they were following a strange region of space. They were not. They were following the shape of uncertainty as it propagated through instruments, through equations, through centuries of assumptions about what reality must be like in order to be measurable. The void was still there, but its importance had shifted. It was no longer only a cosmic feature. It had become a mirror. And in that mirror, the human mind could see the outline of its own limitations with merciless clarity. By the time the next set of observations was scheduled, nobody in the room spoke of finding a final answer. They spoke instead of narrowing the region of ignorance. That phrase hung in the air like a verdict. The universe had not yielded a secret. It had enlarged the perimeter of what could not yet be known. And somewhere inside that perimeter, just beyond the comfort of the current models, the team could feel the presence of something waiting, not necessarily conscious, not necessarily hostile, but profoundly unaccounted for. The cosmos had become less like a map and more like a question that was learning to ask itself back. The next observations arrived before anyone was ready for them, as if the sky had grown impatient with human caution. New exposures taken from a different hemisphere and under different atmospheric conditions confirmed the same hollow geometry, but now the void seemed to extend farther than the earlier maps had allowed. Its boundary was not fixed. It drifted, not in the crude sense of a shifting cloud or a moving shadow, but in a far more unnerving way. The contour changed, depending on which statistical lens was applied to it. A structure that should have remained stable under different methods instead appeared to reorganize itself around the act of being measured. The effect was small, but in cosmology, small deviations can become tyrants, and this one had the icy discipline of something that knew where to hide. The team redoubled the internal checks. They interrogated every step in the reduction pipeline, every assumption hidden in code, every correction normally treated as too mundane to matter. A malfunction in the photometric calibration could distort the inferred density field. A bias in the redshift sample could exaggerate an underdensity. A selection effect in the survey footprint could carve an artificial geography into the sky. These were not lazy possibilities. They were the first line of defense against self-deception. But one by one, they failed to explain the way the anomaly behaved across independent datasets. The void persisted, yes, but the unnerving detail was the presence of a faint asymmetry in the surrounding distribution that repeated in unrelated observations with almost surgical precision. It was as though the universe had left the same fingerprint on different windows of light. A senior analyst suggested that the problem might lie in the interpretation of background subtraction. Deep imaging is never pure. It is built by removing everything nearby enough to confuse the eye, leaving behind the faint architecture of the distant universe. But subtraction can be treacherous. If the field contains a genuinely unusual large-scale feature, then what gets removed as background may in fact be part of the signal. The team revisited the original frames, expanding the field of view, changing the baseline, adjusting the sky model, and there it was again, refusing to vanish. The structure was larger than the initial maps had shown, and its outer edges merged with filamentary stretches of lower than expected density that seemed to trace a path through neighboring sectors of the cosmic web. The void was no longer singular, it was connected. That connection was the first truly frightening thing. A whole can be named and contained. A network of absence is harder to tolerate. The surrounding filaments curved around the region in ways that suggested not just gravitational influence, but a kind of large-scale reluctance, as if matter had once flowed toward that patch and then avoided it. The effect reminded one theorist of fluid around an obstacle. But there was no obstacle visible, no mass concentration to repel the flow, only the negative shape itself. In the room, the conversation grew quieter. People began to choose their words more carefully. They were no longer asking what created the void. They were asking what it was doing to the surrounding universe. Meanwhile, the infrared data deepened the mystery by adding thermal structure, where cold emptiness should have been simplest. Along one edge of the void, a thin band of marginally warmer dust emission appeared across multiple bands, too coherent to be random and too weak to announce itself directly. The feature could have arisen from hidden star formation in faint galaxies below the detection limit, but the spectral signatures were wrong. It looked like a boundary condition rather than a source. Something had altered the local environment, not by shining on it but by changing the terms under which matter assembled there. And this led to something more disturbing. If the boundary was real, then the void may not be an empty region at all. It may be the wake of something that passed through. Nobody wanted to say that aloud. Passing through what? Through space, yes, but also through the assumptions by which space is interpreted. The word wake implied motion and event, both of which were difficult to assign to a region of the universe millions of light years across. Yet the data encouraged that impression. In some maps, the void looked like a corridor, in others a crater, in others still an unfinished geometry whose missing volume seemed to define the surrounding mass more clearly than the matter itself. When the team overlaid the various wavelength maps, the boundaries aligned too well to dismiss. Not every edge matched exactly, but enough did. The pattern was now large enough to feel intentional, even if intention remained the wrong word. A few weeks into the deeper analysis, the collaboration received a completely separate set of observations from a radio array working far from the optical surveys. The radio sky is noisy in a different way. It carries the hum of active galaxies, jets, hydrogen structure, and the faint background murmur of the early universe. In that data, too, there was an irregularity. Not the same void, not in any literal spatial correspondence, but a subtle distortion in the distribution of low-frequency background fluctuations that mirrored the larger anomaly's asymmetry. The same statistical slant had appeared in a completely different messenger. And what scientists realized next was even more unsettling. The problem was not isolated to matter distribution. It seemed to reach into the consistency of the universe's signals themselves. At first, the radio team proposed instrumental drift, then ionospheric contamination, then foreground interference from our own galaxy. Each explanation had merit. Each was tested. Each was partially ruled out. The remaining distortion survived the corrections that should have erased it. It was as if the universe was speaking through multiple channels in a tone too subtle for any one instrument to fully catch, yet too persistent to ignore once heard. The lead investigator began to compare the situation to a chorus singing slightly off-key in different rooms of the same building. If that was true, then the issue was not an isolated voice. It was the structure of the building itself. Inside the cosmology group, the word anomaly stopped sounding adequate. An anomaly is an exception within a stable frame. This was no exception. It was an interlocking set of exceptions that seemed to emerge whenever the cosmos was inspected with enough depth. The current best-fit model of cosmic expansion still worked, technically. It still described the average behavior of a universe dominated by dark energy and dark matter, with baryonic matter forming stars, planets, and the narrow islands of visibility that give human beings a foothold in the dark. But the void suggested that the averages might conceal dynamic irregularities, too large to fold back into the margins. The model did not fail. It simply began to feel incomplete in the most dangerous way possible. Not because it was wrong everywhere, but because it was right only where the universe chose to cooperate. That realization infected every discussion after that. A theory can survive one uncomfortable datum. It can survive many. What it cannot easily survive is the possibility that the universe's observed regularity is a local convenience, a statistical calm sitting on top of a deeper turbulence. The void was now being discussed alongside non-standard expansion histories, evolving dark energy equations of state, and alternate gravity frameworks usually kept at the edge of respectable discourse. Modified gravity could, in principle, affect the growth of structure. It could change how voids form and how matter flows around them, but every modified model carried its own burden. To explain one discrepancy, it had to disturb other well-tested observations. The balancing act grew more precarious with every attempt. And this is where the story becomes darker, because every physical explanation began to reveal a philosophical cost. If gravity behaves differently on vast scales, then the laws we trust may be only approximations to a more elaborate system. If dark energy evolves, then cosmic expansion may not be a passive stretching toward cold dispersal, but a process with hidden instability. If the void reflects non-standard structure formation, then the universe's history may be less uniform than cosmology has assumed. Each route into explanation was a corridor with another locked door at the end. No matter which one they opened, they stepped into a larger room of uncertainty. The mystery was no longer growing merely in size, it was growing in depth. By then, the imagery from the deep field had become almost unbearable in its quietness. There were no cosmic fireworks in the region, no dramatic jets, no bright cluster to seize attention. Instead, there was a subdued, almost clinical vastness. Distant galaxies, each one a congregation of billions of stars, hung in the field like neglected embers. Between them lay gulfs so large that human imagination had to distort itself to accept them. And somewhere inside that gulf was the void, the absence around which the rest of the sky arranged itself. The researchers kept returning to the images because, despite the numbers, the visual impression mattered. The eye sensed a wrongness the equations had not yet fully named. You are looking at a universe that appears almost empty, and then you notice that even the emptiness has structure. The deeper they examined the void, the more they noticed that nearby galaxies did not merely recede from it in the expected Hubble flow. Some exhibited residual motions inconsistent with simple expansion. A handful seemed tugged sideways by a force not captured by the visible mass distribution. The local velocity field became a kind of topographical map of pressure and release, with the void sitting in the center like a missing organ. Could this be explained by dark matter substructure? Possibly. Could it be a coincidence of peculiar velocities? Maybe. Could the entire region be part of a much larger underdense superstructure extending beyond the survey's horizon? That was possible too. But every larger structure introduced a more troubling implication. If the void extended beyond the observable patch in ways the initial maps could not capture, then the anomaly might reach into areas our instruments had not even begun to sample. So they expanded the search. Wider fields, longer baselines, different redshift slices. The sky became a deeper theater of absence. Other voids emerged, not identical but strangely related in scale and shape. One elongated region lay along a filamentary channel of reduced density. Another showed a cold spot in the background microwave structure that coincided with an unusually sparse galactic distribution. The patterns were not perfect matches, but they shared enough traits to force a disturbing question. Was the original void truly unique, or had it only been the first one large enough for us to notice? If there were many such regions, then the universe might be threaded with far more instability than the standard picture admits. This is the point at which the narrative turns inward. because the instrument is no longer the telescope, it is the mind. The researchers began to experience a kind of cognitive fatigue that came not from the workload, but from the shape of the problem itself. Their discussions looped through explanation after explanation, each one elegant until tested, each one incomplete once the next dataset arrived. A few stopped sleeping properly. One member of the team confessed that the void had started appearing in his dreams not as a location, but as a condition of vastness pressing against every known object. Another said that when she looked at the night sky from the observatory terrace, she no longer saw stars first. She saw the intervals between them. That shift, once noticed, was hard to undo. The intervals became the obsession, because the universe is mostly interval. The bright objects we cherish are exceptions. The spaces between them are the rule. Yet humans evolved to seek form inside scarcity, to find pattern across emptiness, to turn distances into narrative. The void exploited that instinct by becoming legible without becoming understandable. In some respects, that is more unsettling than a direct threat. A predator can be faced, a storm can be anticipated, but a universe that invites measurement while withholding meaning forces the observer into a state of permanent incompletion. The data existed, the uncertainty remained, the gap between them widened. Then came the gravitational lensing analysis that changed the conversation again. Light from background galaxies passing near the void's boundary should have been distorted by the mass distribution nearby. Instead, several arcs suggested an influence slightly stronger than the observed visible matter could account for, even after including the expected dark matter halo. The discrepancy was small but consistent. The team tested whether line-of-sight structures could explain the excess. They could not. They tested whether the lens models had been misparameterized. They had not. The result implied either a hidden mass concentration, some exotic interaction, or a non-trivial correction to how space-time curvature was being inferred on those scales. In ordinary times, that would have been a fascinating technical problem. Here it felt like the void was bending not just light, but the confidence with which light can be interpreted. At the next meeting, someone asked whether the anomaly could be connected to the broader question of cosmic acceleration. If dark energy dominates the fate of expansion, then perhaps its influence is not uniform. Perhaps the vacuum energy that drives the universe apart varies subtly across regions, leaving local pockets where expansion accelerates differently. That idea was not absurd. It had precedence in speculative models, though none widely accepted. Yet if dark energy were patchy, then voids might be more than empty regions. They might be zones where the pressure of expansion has changed the local meaning of distance. Theoretically, it was possible. Emotionally, it was catastrophic, because it suggested the universe's largest-scale behavior might not be a stable backdrop at all, but a field of conditions shifting beneath every observation. But it goes deeper than that. If the expansion of space can vary locally, then the cosmological principle, the assumption that the universe looks roughly the same in every direction on large scales, becomes a convenience rather than a certainty. And once that principle weakens, every derived parameter becomes vulnerable to reinterpretation. The age of the universe, the inferred density of matter, the calibration of standard candles, the mapping of distance itself, all of it rests on an architecture that assumes more uniformity than the data may allow. The void thus became a wedge, prying open the entire structure of cosmological inference. It was no longer a question of one anomaly. It was a question of whether our picture of reality depends on a symmetry that may not actually exist. Around this time, the team began comparing notes with researchers studying large-scale flows and bulk motion anomalies. There were hints in the literature, uncomfortable, unresolved hints, that the local group of galaxies might be moving in directions not fully explained by known mass concentrations. A so-called attractor had long been discussed, a gravitational influence drawing structures in a particular direction, but the full vector field remained difficult to settle. When the void's position was projected against those flow maps, the alignment was almost too neat. The region seemed to sit near a boundary where motions converged and then slipped around something unseen. That gave rise to a chilling suspicion. Perhaps the void was not merely empty because matter failed to gather there. Perhaps matter had been diverted. Diversion implies agency, even when none is intended. A river is diverted by a dam, a crowd by an obstacle, a path by a presence. In cosmology, the term feels uncomfortable, yet the visual evidence made it hard to avoid. Matter was not simply absent from the region. It appeared to have been redistributed in ways that preserved an emptiness at the center. That center became more significant the longer they studied it. If there was a source of disturbance, it might be too faint, too diffuse, or too non-luminous to detect directly. But perhaps direct detection was the wrong expectation. Perhaps the universe was not revealing objects so much as conditions, a distortion of probabilities, a local weakness in the assumptions that govern clustering, a place where the emergence of structure had been interrupted by something we cannot yet name. The word interrupted lingered. It implied a process underway, then halted. Structure formation, halted. Light distribution, interrupted. The normal accumulation of matter into stars, galaxies, clusters, the whole slow choreography of cosmic organization, appeared in the void's vicinity as if it had stumbled. Not stopped forever, perhaps, but slowed, warped, postponed. That raised an even more uncomfortable idea. What if the universe contains regions where time itself, in the practical sense of developmental history, does not unfold in the same way? Not time dilation, in the simple relativistic sense, but a difference in the rate at which complexity accumulates. In some areas, stars ignite early and burn. In others, filaments remain thin, matter stays sparse, and the landscape of existence lingers in a state of cosmic underdevelopment. The void might be a geographical expression of that asymmetry. Entropy returned to the center of the conversation, but now it sounded less like a law and more like a destination. The universe is moving toward an arrangement in which gradients fade and usable energy dwindles. Heat death is the long horizon where everything spreads thin, yet the void's peculiar structure suggested that the path toward entropy might not be smooth. It might contain eddies, delays, regions where order resists its own dissolution, and regions where dissolution arrives too early. If one patch of the universe can hold back or accelerate the march toward equilibrium, then the cosmos is not simply aging, it is differentiating its aging. That possibility is haunting because it makes cosmic fate feel less like a single outcome and more like a terrain with hidden slopes. As the modeling grew more desperate, a few researchers attempted to quantify the void's internal probability structure using Bayesian reconstructions that incorporated every available prior from structure formation, lensing, and expansion history. They expected uncertainty. What they did not expect was the unnerving sharpness with which the posterior distributions split around mutually incompatible solutions. One family of models favored a truly extreme underdensity, almost empty enough to strain formation histories. Another favored a more moderate void embedded in an unusual dark matter environment. Another required a fluctuation in the early universe that sat at the edge of statistical plausibility. The models did not converge. They diverged like witnesses to the same event who can agree only that something happened and that it should not have. This failure of convergence spread beyond the analysis. It began to infect conversations about the reliability of cosmology itself. The science was not collapsing. That would have been simpler. It was doing something more unsettling, remaining functional while visibly fraying. The equations still worked well enough to describe most of what was seen. The problem was that most had always been the shelter under which certainty lived. Now the shelter had a hole in it, and through that hole one could see how thin the ceiling really was. The void had become a demonstration that the universe can behave consistently enough to build a civilization upon, while still containing regions where consistency no longer feels guaranteed. A late-night session produced an image that nobody on the team forgot. It was a composite of optical, infrared, and lensing data, stacked together to emphasize structure around the void. The result looked less like a map and more like an anatomy. Threads of matter stretched across darkness like nerves across a skull. Dense knots of galaxies formed at the periphery. The center remained deeply underpopulated, but the surrounding rim showed a complexity that made the void seem less like a hole and more like a cavity left by a removed organ. One of the postdocs stared at it for a long time, then said that the universe no longer looked empty. It looked as though normal structure formation had been disrupted. That word changed everything. Edited implies alteration after the fact. It suggests selection, omission, revision. It suggests that the version we observe is not necessarily the original one. No one in the room meant that literally. The cosmos is not a manuscript, and yet the image carried the strange force of revision. If some process had altered the local balance of structure, then the void was the trace of that alteration. The question then became brutally simple. Altered by what? By rare physics? By a massive but invisible structure? By a failure in our assumptions? By something deeper than the standard framework of cause and effect can comfortably contain? The team's work began to attract outside attention, and with it came the familiar pressure to interpret, to simplify, to deliver a clear statement about what had been found. That pressure only sharpened the sense that clarity was becoming impossible. Public language wanted a noun. It wanted an object. It wanted the answer to be something that could be filed under dark matter, cosmology, or observational bias. But the void was teaching the researchers that some discoveries do not resolve into a single label. They expand the category from which the label must be chosen. The more they tried to classify it, the more the classification system itself seemed to tremble. One evening, a theorist who had remained skeptical longer than the others finally said what many had been circling around. If the void is real in the way the data suggests, then our descriptions are not just incomplete, they are possibly misframed. It was a careful sentence, but the room heard the force beneath it. Misframed means that the issue is not a missing piece inside the picture. It means the picture's boundaries may be wrong. It means there may be aspects of space-time, matter, or observation that do not fit within the conceptual window we've cut into reality. And suddenly the mystery had shifted again. From where is the void, to what kind of thing is a universe that produces voids like this? Outside, above the mountain observatory, the Milky Way cut a pale scar across the sky. From a human perspective, it is one of the most beautiful sights imaginable. A luminous band made of countless stars so distant they fuse into a soft river of light. But at that hour, under the weight of the new analysis, it appeared less like beauty and more like evidence. Even our own galaxy is only a small island in the dark. Beyond it, galaxies retreat into the black. Beyond them, the voids multiply. Beyond those, the background glow of the early universe still lingers, an echo of a time when everything was hotter, denser, and more obedient to the equations we apply now. Yet if one region can expose inconsistency at this scale, then the distance between certainty and illusion may be far thinner than anyone wants to admit. The next contradiction arrived from an unexpected place. A careful study of entropy in simulated universes tailored to match the void. Researchers asked whether the void could emerge from rare but natural fluctuations over cosmic time. The answer, in the strictest statistical sense, was yes. But the required conditions were so precise, and the resulting structure so unlike surrounding regions, that the simulations began to look less like evidence and more like warnings. They showed that once certain thresholds were crossed, the universe could produce pockets of extraordinary sparsity, while still preserving global averages. Those pockets, however, tended to distort neighboring regions in ways that made the long-term fate of nearby structure uncertain. In the models, the void wasn't just a void, it was a source of cascading irregularity. That notion carried a strange emotional weight. A void as a source, absence as a generator. It is a deeply unsettling inversion, because human thought associates generation with abundance, not subtraction. But in a universe ruled by gradients and thresholds, a deep enough absence can shape the flow around it more decisively than a presence. That may be the hidden lesson of the anomaly. What is missing can exert as much influence as what is there. In philosophical terms, that is already a wound to common sense. In cosmological terms, it threatens the assumption that visible structure is the primary story. What if the story is written instead in what never formed, what dissolved too early, what was diverted, what remains beyond detection because the universe itself has arranged an architecture of concealment? By now, the questions had taken on a colder edge. If the void is a consequence of ordinary physics pushed to an extreme, then physics still holds. If it is a sign of additional physics, then nature is more elaborate than current models. But if it is neither, if the anomaly arises from a deeper instability in the act of observing reality, then the problem becomes existential in a way no grant proposal can politely contain. The instruments rely on the assumption that light arriving from the distant cosmos carries information in a predictable form. Yet what if predictability itself is conditional? What if the path between event and observation is not always transparent? What if the universe permits certain truths only in partial, distorted, or delayed form? That question haunted the lead astronomer the most, because it undermined the profession's most sacred conviction, that the sky, however vast, remains decipherable in principle, not perfectly, not without effort, but decipherable. The void suggested a more humiliating possibility. Perhaps some aspects of reality are not merely hidden from us. Perhaps they are inaccessible because the methods of access transform them beyond recognition. This is not the same as saying the universe is unknowable. It is worse. It means our knowledge may be interaction dependent. The act of looking may change the thing looked at in ways that become fatal to certainty at the largest scales. And if that is true, then cosmology is not an archive of the universe. It is a negotiation with it. The collaboration assembled one last cross-disciplinary review before the next cycle of observations. Astrophysicists, statisticians, instrumentalists, theoretical cosmologists, and data visualization specialists sat in the same room, surrounded by projections of the void in various wavelengths and representations. The images glowed like evidence from a case no one wanted to close. Someone pointed to the deepest, underdense center. Someone else traced the curved boundary of the filamentary edge. Another overlaid the cosmic microwave background anomaly. Another plotted the expansion residuals. And when all of it was superimposed, the result was almost obscene in its coherence, not because it explained itself, but because it appeared to resist explanation through sheer internal consistency. The group fell quiet. For a long time, no one spoke. Then the oldest member of the team, who had spent 4 decades measuring the sky and had seen several revolutions in method and interpretation, leaned back and said something that sounded less like a conclusion than a confession. We may be standing at the edge of a regime where the universe behaves differently from the one our mathematics was built to describe. Nobody objected. Nobody could. The sentence did not assert new knowledge. It named a loss. It admitted that the maps might not extend far enough, that the model space might be too small, that reality itself could be more varied than the frameworks we inherited were designed to permit. The room felt colder after that, though the temperature had not changed. It was the kind of cold that comes from scale. Outside the windows, the mountain darkness held the observatory in a shell of silence. Above it, the stars continued their indifferent distances, each one a reminder that light is always late, and therefore always partial. Somewhere in that delay, the void remained, but now it no longer seemed like a singular absence. It seemed like an opening, not an opening to a hidden chamber with a tidy answer inside, but to a deeper level of reality, where the assumptions of separation, stability, and legibility may fail together. The team had not found the end of the mystery. They had found a threshold where mystery begins to understand itself, and that is where the fear truly started to take hold, because a phenomenon that changes meaning under increasingly precise observation becomes more than an isolated anomaly. It becomes a mirror with the power to reflect failure back at the one who looks. The void, once treated as a rare structural oddity, had become evidence that the universe might contain layers of behavior beyond the reach of current cosmology, layers that manifest only when measured from certain angles, with certain tools, under certain assumptions. The implications spread outward from there like cracks under a thin sheet of ice. If one part of the cosmos can hide itself this effectively, then what else has been misread? What else has been mistaken for background, noise, or average? What if the deepest structure of reality is not stability, but concealment? The last data packet before the next phase of review contained one final irregularity. It was small, nearly easy to miss, a subtle mismatch between the inferred distance of a background galaxy cluster and the redshift pattern expected from the standard expansion model. On its own, it would have passed without notice, but in the context of everything else, it felt like a whisper from the same unseen hand. The distance scale had bent by a fraction too large to ignore. The team checked it once, twice, then again. Every check pointed back to the same unsatisfying answer. The numbers were real. That meant the void was no longer simply influencing local density maps. It was intruding on the measurement of the universe's size itself. When the universe begins to alter the meaning of distance, the ground beneath cosmology is no longer ground at all. It is a shifting surface over something deeper and darker. The researchers understood this instinctively even before they named it. They stood together in silence, watching a projection of the void suspended in blue light, and the image seemed suddenly less like a discovery than a warning. The cosmos had not offered them a secret. It had offered a limit. Beyond that limit, perhaps the rules still exist, but not in forms we are prepared to recognize. And as the observatory lights dimmed for the night cycle, one terrible thought remained. The deeper humanity looks into the universe, the less certain it becomes that the universe is obliged to look back in a way we can understand. The third night after the review, the observatory did something that had not happened in years. It went nearly silent. Not silent in the romantic sense of a mountain facility sleeping under the stars, but silent in the procedural sense, where each room seemed to hold its breath between scheduled tasks. The analysis cluster hummed, the cryogenic systems kept their patient temperature, and the telescope continued to track its assigned coordinates. But inside the minds of the team, there was a new stillness, the kind that follows a near disaster when everyone is waiting to learn whether the disaster had already begun. They were no longer merely studying the void. They were preparing to discover whether the anomaly was exposing a limitation in the way reality could be observed. The new observations arrived at midnight local time, compressed into a packet of calibrated fields from a southern survey that had been deliberately chosen to be unrelated. That choice was meant as a safeguard. If the anomaly appeared there too, then the odds of coincidence would collapse. When the first images loaded, the room did not react. The sky looked ordinary enough at a glance. Bright foreground stars, distant galaxies, faint streaks where cosmic rays had crossed the exposure. Then the software assembled the field into a deeper composite, and the familiar shape appeared again, not identical, but bearing the same impossible signature. Another region of lower density, another distortion in the surrounding distribution, another boundary that seemed too deliberate to be a statistical accident. But it gets worse. This one was not merely adjacent to a void. It was aligned with the earlier anomaly across an immense span of sky. As if both regions belonged to a larger geometry no one had yet mapped, the alignment should have been impossible. Across such distances, random structures ought to lose any shared orientation. Yet when the researchers overlaid the axes of the two regions, the relationship was so precise that the first assumption was software contamination. They checked the metadata, the pointing history, the astrometric solutions, the reduction pipeline. Nothing linked the fields except the sky itself. And that answer, in its own way, was more alarming than any mistake. Because if the alignment was real, then the universe contained a coherence extending over scales larger than the models had predicted, and the alignment suggested correlations between large-scale structures that existing cosmological models struggled to reproduce. Suddenly, the void did not seem local. It seemed connected to architecture, a cosmological structure that large would have to be explained either by extraordinary initial conditions, unusual dark matter behavior, or a revision to the way expansion and clustering interact on the grandest scales. The team ran the possibilities in parallel, and each path twisted into a new contradiction. If primordial fluctuations created the alignment, then inflation must have produced a directional imprint far more organized than standard theory allows. If dark matter arranged it, then the invisible mass must not only cluster but coordinate over staggering distances. If dark energy shaped it, then the smooth push of expansion would have to possess local and directional variation. Every explanation was a door opening onto a chamber that made the original room look simple. The mystery was not shrinking into understanding. It was unfolding into a larger map of what understanding cannot yet hold. The danger in such moments is not panic, it is normalization. Scientists are trained to absorb surprises, to integrate anomalies into broader frameworks, to become comfortable with the unbearable until it becomes a parameter. But some discoveries resist domestication. The alignments kept returning. They appeared in unrelated catalogs, at different wavelengths, in fields separated by enough cosmic distance to make the recurrence feel less like coincidence and more like recurrence as a property of the universe itself. The team began to speak of the pattern in lowered voices, as though naming it too directly might encourage it. A few joked nervously about staring too long into the abyss. Nobody laughed, because the abyss in this case seemed to have a preferred orientation. The second wave of infrared follow-up revealed another layer. What had looked like a uniform boundary around the first void now contained small zones where the stellar population differed subtly from expectation. Not enough to imply a local galaxy cluster, not enough to alter the gross statistics, but enough to suggest that the void's edge had been shaped by processes operating over an extended history, perhaps involving repeated episodes of matter evacuation, delayed collapse, or interactions with structures beyond the current survey limit. The problem with any of those explanations was the same. They all assumed the void had a history consistent with ordinary cosmological progression. The data no longer encouraged that assumption. The edge seemed not just to exist, but to remember. Memory in astrophysical structures is a dangerous idea because it feels poetic until it becomes measurable. A region of space cannot literally remember in the human sense, but a history can be encoded in density contrasts, thermal imprints, gravitational residuals, and the motion of surrounding bodies. That is what the team began to suspect. The void might be carrying a record of an event too ancient, too diffuse, or too fundamentally alien to be captured as a single cause. This record was not like sediment laid down by time. It was more like a pressure echo, a long, fading consequence of a disturbance that never fully stopped resonating. And if that was true, then the universe was not merely full of structure. It was full of leftovers. Leftovers are ordinarily harmless. In cosmology, they are often the most beautiful things we have. The cosmic microwave background, the afterglow of the early universe, the fossil radiance of a time when everything was trapped in heat and ionized fog. But this was different. The remnants they were seeing did not feel like a fossil. They felt like a wound still deciding how to close. A spectral kink here, a lensing bias there, a flow asymmetry beyond the void's perimeter. When assembled, the pieces formed a chronology that refused to settle into any single epoch. Some signatures suggested an early origin, others hinted at recent dynamical influence. It was as if the region had been disturbed at multiple times by the same underlying instability. That possibility made the problem much less containable. One of the theorists, exhausted and increasingly blunt, proposed that they might be looking at an effect of vacuum metastability. The vacuum of space in high-energy physics is not necessarily the absolute lowest energy state. It may be only a temporary one, stable enough for cosmic timescales, yet capable under extreme conditions of transitioning to another state. In most settings, that concept remains abstract, a theoretical elegance more than an immediate threat. But if even small regions of the universe could sit near such a threshold, then a void might not just be empty. It might be a place where the local vacuum configuration differs subtly from elsewhere, altering expansion, particle behavior, and structure formation in ways that resemble the observed anomalies. It was a terrifying thought because it translated the mystery into a language of fragility. The universe itself might be precariously balanced on a state we have mistaken for permanence. Nobody wanted to say that the sky could be unstable. It sounds absurd until the evidence starts to resemble the accusation. If the vacuum is not universal in its properties, then the physics of one region need not match the physics of another. That would change everything. It would mean particle masses, interaction strengths, and even the way light propagates might vary by environment on scales far larger than laboratory tests can access. The voids could then be the visible trace of regions where reality is slightly out of register with the surrounding cosmos. This is not the sort of hypothesis that calms a room. It makes the room feel too small to contain the conversation. They sought independent confirmation from gravitational wave data, hoping for some sign that space-time itself had carried a trace of the anomaly through violent cosmic events. The available background noise was sparse, but not empty. The patterns were subtle, buried under unresolved sources and detector limitations. Still, there were hints, tiny statistical unevenness in the background distribution, not enough to claim detection, but enough to add unease to the collection. The same sky that had once seemed like a passive canvas now appeared to be nudging every messenger that crossed it. Light, radio waves, background radiation, the inferred motions of matter, all of them carried a faint irregularity, as if the universe's surface had been brushed in one direction by an unseen hand. And what scientists realized next was even more unsettling. The irregularity was not uniform across instruments. It appeared strongest when the observational methods depended on long integration times and the assumption that the sky remains statistically stable during the measurement. That should have been reassuring because it meant the effect could be instrument-dependent. Instead, it produced a deeper anxiety. If the anomaly becomes clearer with exposure time, then the act of observing it may be part of what reveals it. The measurement is not passive, it is cumulative. The longer the sky is watched, the more it seems to disclose a structure that was not visible at first. But disclosure is not the same as explanation. It can just as easily be a slow surrender of the unknown. The lead astronomer started to keep a private log, not of technical details but of impressions. That would have been unthinkable earlier in the project. Now it felt necessary. He wrote down how the void looked at different hours, how the data seemed to tighten around certain parameters, how the uncertainty behaved like a living perimeter. He did not write that he felt watched, because that would have sounded foolish even to him. Instead, he noted that each new fit made the original region feel less like a location and more like a condition under which the model had to operate. This was not a statement of fact. It was an admission of atmosphere. Yet atmosphere matters when a mystery begins to dissolve the line between physical anomaly and psychological pressure. In the control room, the maps multiplied. Projection after projection covered the walls. Density reconstructions, redshift slices, temperature anisotropies, weak lensing fields, velocity residuals, entropy forecasts. The results did not converge. They built upon each other, each one adding a little more weight to the same invisible center. The void could not be made to disappear by any one correction. Worse, each correction emphasized a different aspect of its presence. If the density field was adjusted, the lensing discrepancy became more apparent. If the lensing model was revised, the flow asymmetry stood out. If the velocity bias was accounted for, the infrared boundary sharpened. The anomaly was not one thing. It was a shape revealed by every attempt to flatten it. That realization pushed the group toward a new line of inquiry. Perhaps the void was not a structure in matter at all, but in the distribution of information. The idea sounded wild, but not absurd enough to ignore. If certain regions of the sky are effectively harder to measure because of correlated noise, lensing degeneracies, foreground contamination, or expansion-related distortions, then what appears as a cosmic absence might partly reflect a limitation in how information propagates from there to us. But no sooner had the idea been voiced than it began to fracture. The anomaly persisted across independent messengers. It was not a single-channel failure, so the question changed again. What if the distortion lies not in the messenger, but in the path itself? The path itself, light traveling across billions of years, gravitational gradients subtly shaping trajectories, expansion stretching distances, all of it traversing a universe whose emptiness is not empty in the way human intuition imagines. Because interstellar and intergalactic space is not a void of nothing. It is filled with faint particles, fields, background radiation, and the silent domination of the unseen. Yet the anomaly implied a deeper emptiness, a region where the standard accounting of everything in transit became unreliable. If paths can be altered in ways our measurements cannot fully disentangle from sources, then the cosmos becomes less like a set of objects and more like a problem in navigation through a medium whose properties may be changing while we cross it. A graduate researcher made the mistake of asking whether the void might be expanding faster than the surrounding universe. The question hung in the room with an almost offensive clarity. Could a local region of lower density, under the influence of dark energy, recede and rarefy at a slightly different rate? Theoretically, such environmental dependence could create differential expansion. But if that were happening on the observed scale, then the surrounding geometry should be far more disturbed than it was. Still, the idea could not be dismissed outright. It fit too neatly with the sense that the void was not merely absent matter, but active departure. The region seemed to be leaving behind not just less density, but a changed measure of distance. The measured distances were the next thing to destabilize. Standard candles in and around the region returned values that could not be reconciled easily with the rest of the survey. The discrepancy was modest, but in cosmology, modest discrepancies are often where revolutions begin. If the distances were truly off, then the inferred expansion rate nearby might differ from the global mean. That would be enough to alter the estimated size of the void, which would in turn affect gravitational calculations, which would in turn alter the interpretation of the lensing residuals. The loop was vicious. Every corrected estimate changed the next one. The void had become a dependency tree with no stable root. This is the point where dread begins to feel intellectual. It is no longer a vague emotion produced by darkness and scale. It is an unavoidable response to a system whose outputs refuse to stay fixed long enough to support confidence. The researchers could still do their work. They could still publish, classify, and debate. But under all of it was the growing suspicion that they had crossed into a regime where the universe's behavior near certain thresholds is not merely unmodeled, but unstable in principle. Not because nature is capricious in a childish sense, but because the assumptions used to simplify it may fail when confronted with enough distance, enough emptiness, and enough time. A meeting that should have lasted an hour stretched into the early morning. By then, everyone was tired enough to speak with dangerous honesty. One astronomer admitted that she no longer trusted the phrase large-scale homogeneity in the same way. Another confessed that every reference map now looked provisional, as though the universe had been too big to average correctly. The theorists argued about whether the anomaly indicated new astrophysics, new cosmology, or a failure of epistemology itself. That last term made the room go still. Epistemology sounded too abstract until they realized it meant the conditions under which any claim to know can survive. If those conditions are compromised, then the problem is not only what the universe is, it is whether we can ever be sure what it is. Somewhere in the darkness outside, a wind moved across the mountain ridge, and the building creaked in response. The sound was ordinary, but it landed with strange force because the team had spent so many hours in the company of silence that any intrusion felt amplified. They returned to the images. They always returned to the images. The voids glowed faintly under false color, one region mapped in amber, another in violet. The surrounding structures marked with lines and contours that made the emptiness seem almost sculpted. But the more they annotated it, the more they sensed that the annotations were circles drawn around a thing that refused to remain inside them. The void was not being captured. It was enlarging the frame. The deepest test came from the combination of void maps and entropy forecasts. If the region represented a local acceleration toward heat death, then one would expect a certain ordering of surrounding structures, less star formation, more dispersal, weaker gradients in gas density. But some of the metrics contradicted that expectation. In isolated pockets near the boundary, there were signs of unexpectedly coherent motion, as if matter had been organized before being evacuated. The entropy story was incomplete. Rather than a simple march toward disorder, the data suggested alternating states of arrangement and release, like a system breathing on timescales too large for us to perceive comfortably. That image was beautiful and horrifying at once. A breathing universe implies rhythm. Rhythm implies behavior. Behavior implies something about the cosmos is not fixed in the way we hoped. And then came the contradiction that tipped the room from concern into alarm. A follow-up observation, optimized to target the supposed center of one void, found that the center was not where prior maps had placed it. The difference was small in angular terms, but large enough to matter. More troubling still, the offset was not random. It pointed toward a region of sky previously associated with one of the other anomalous alignments. The implication was impossible to ignore. The voids might be arranged relative to one another in a larger geometry, their apparent centers shifting because the true structure spans beyond the region any single survey can capture. The mystery was no longer about a hole in the sky. It was about a pattern of holes whose combined shape remained hidden in plain sight. That evening, the lead astronomer stood alone on the observation deck and looked up at the black between stars. The sky was so clear it felt almost surgical. He had spent his life believing that distance is a quantity to be measured, and now distance seemed more like an experience of disconnection, an emotional fact embedded in physics. The nearest galaxies were still unimaginably far. The farthest visible structures were unreachable in every practical sense, and between here and there stretched a universe whose emptiness had begun to behave like content. He thought of all the light that had crossed that emptiness to reach him, carrying news from dead stars and ancient collisions, and he felt, more than anything, the burden of arrival. Each photon was a witness. Each observation was testimony, and yet the testimony was changing shape under scrutiny. The team finally decided to compare the anomaly against cosmological simulations, not just of density and expansion, but of observational epistemics, what the universe should look like to a civilization limited by finite light speed, finite resolution, and finite patience. It was an odd exercise, but the results were grim. In nearly every plausible model, an advanced observer should be able to extract the dominant large-scale parameters with improving precision over time. Yet the void regions seemed to generate diminishing returns. Better instruments produced better measurements, but not better closure. The more complete the data became, the more the interpretation branched. That should not happen. Precision is supposed to tame ambiguity. Here it refined it into sharper forms. This was the point of no return, though nobody said it. The team had crossed from finding something strange into confronting a possibility they could not comfortably phrase. Perhaps the universe is not merely more complex than current physics, but partially resistant to being rendered into a single coherent picture. If so, then the void is not just a cosmic feature. It is a demonstration of the limits of synthesis. The observatory, the software, the language, the models, the human mind itself, they all remain necessary, and all of them now looked vulnerable. In the face of the anomaly, every tool became both indispensable and suspect. Then the oldest member of the collaboration asked for all the intermediate residual maps, not the final polished ones. He wanted the messy layers, the versions with obvious imperfections. When he overlaid them, a pattern emerged that no one had noticed because it was too faint to survive the drive toward summary. Across multiple independent reductions, the same directional skew appeared in the residual field, each time faint, each time aligned. It was not a telescope artifact, it was not a reduction artifact. It was an implication artifact, the kind of signal that remains when every obvious thing has been removed and something still refuses to go. He sat back from the screen and said nothing for a long while. Then, very quietly, he asked whether they had been assuming the wrong origin altogether. The possibility was that the voids were not the cause of the anomalies, but the consequence of something else entirely, something stretching across the cosmos in a structure too diffuse for direct detection, a network of influence, a hidden relationship between expansion, mass distribution, and background radiation. Or perhaps something even harder to name, a regime where space-time and observation become entangled over intergalactic distances, producing pockets of apparent emptiness that are actually regions of altered interpretive stability. The phrase sounded absurd when spoken aloud, yet it left behind the same cold residue as the best explanations. The sense that the universe may have rules we have not yet found the language to express. What makes this more disturbing is not only that the voids remain unexplained, but that every proposed explanation increases the scale of the problem. If the anomaly arises from dark matter structure, then the invisible majority of the universe is more complex than assumed. If it arises from dark energy variation, then cosmic expansion is less uniform than thought. If it arises from early universe scars, then the beginning was rougher and more fragmented than the standard narrative suggests. If it arises from observational limitations, then our confidence in any deep cosmic claim becomes conditional. But if it arises from some deeper instability in the framework of reality itself, then even the distinction between explanation and observation begins to wobble. At that point, science does not stop working. It becomes aware of its own borders. The sky outside the observatory did not change. That was the most unnerving part. The stars continued their ancient calibration. Galaxies burned far beyond sight. The darkness remained open and apparently obedient. But the team could no longer look at the black between objects as neutral space. The voids had taught them that emptiness may contain structure, and structure may conceal behavior, and behavior may outgrow the models built to hold it. Somewhere beyond the reach of their current instruments, the universe was either more intricate than any of them had expected, or more unstable than they had dared imagine. And because the data would not resolve into a single answer, the question deepened instead. If reality can produce contradictions this subtle, then what other laws have we mistaken for certainty simply because we have not yet looked long enough? By the time the fourth wave of analysis began, the team was no longer acting like a group of astronomers responding to an interesting irregularity. They had become custodians of a problem that seemed to be changing the terms of its own existence. Every new calculation arrived with a shadow of uncertainty attached to it, not because the math was weak, but because the context kept slipping out from under it. The voids were still there. The alignments were still there. The distortions in distance, lensing, and expansion had not faded. But now there was a new and more corrosive question hovering over everything. If the universe can hide a pattern this large for this long, what else have we been mistaking for background? The question did not remain theoretical for long. A completely separate observatory, operating with a different instrument suite and an entirely different reduction pipeline, sent word of a nearly identical deficit in galactic density at a corresponding angular scale. Not the same region of sky, not the same coordinates, but the same kind of structure, the same broad geometry of absence, the same faint distortion around the perimeter. This was not a one-off anomaly anymore. It was a recurrence. And recurrence is the moment when randomness begins to look like architecture. The scientists compared notes across time zones, their voices threaded with disbelief that none of them tried to hide. They had expected an isolated oddity. Instead, the sky seemed to contain repeating conditions, as though some invisible rule were being expressed in multiple places at once. The team turned toward simulations with a kind of desperate reverence. They fed the models more exotic parameter spaces, letting dark matter interact with non-standard feedback, allowing dark energy to evolve with redshift, relaxing assumptions about Gaussian initial conditions, and testing alternate gravitational formulations that had once lived comfortably on the fringes of the field. Some runs generated broad cavities, some produced irregular flows, a few even hinted at aligned low-density regions, but none reproduced the totality. Each success came with a failure attached. A stronger fit to void size ruined the lensing signal. A better match to bulk flow destroyed the observed boundary sharpness. A plausible expansion history made the entropy profile impossible. The models did not collapse. They multiplied contradictions with a clinical calm that made the room feel smaller. It is one thing to discover that the universe is more complicated than expected. It is another to discover that complexity itself may be part of the mechanism hiding the answer. The more variables were introduced, the more the anomaly seemed to sit at the intersection of several incomplete stories. One story belonged to the large-scale structure of matter, another to the changing expansion of space, another to the early universe and the fossilized temperature patterns of the cosmic background, another to the limits of the instruments and the assumptions built into them. The voids occupied the overlap between all of these. They were not merely objects. They were the place where explanations began to interfere with one another. A particularly unsettling clue emerged from the background radiation analysis. In a region corresponding loosely to the broader void network, the microwave anisotropy map showed a subtle cold feature that refused to align with the usual statistical expectations. It was not dramatic enough to command attention in isolation, but placed beside the voids it looked like the older echo of the same disturbance. The problem was not that the feature was impossible. The problem was that it had a directional consistency shared by the more recent structures, as if the early universe had already been leaning toward the pattern they were now observing in deep space. If true, then the anomaly was not local, not recent, and not incidental. It was stitched into cosmic history. The implications of that were enormous, and everyone in the room understood them at once. If the imprint reached all the way back to the cosmic background, then the strange behavior in the voids might be the late-life expression of something primordial. But that created another contradiction. The background should have been extraordinarily smooth after accounting for inflationary fluctuations, with only tiny perturbations surviving. A pattern large and coherent enough to seed these voids would have required either exceptional initial conditions or a flaw in our assumptions about how early universe smoothness translates into the structures we see now. In plain language, it meant the universe may have started off with a hidden asymmetry we have not yet learned how to recognize. The idea of a hidden asymmetry spread through the collaboration like a chill, not because asymmetry is rare, cosmology is full of asymmetries, but because this one seemed to operate at a scale that affected almost everything. If the primordial field had a bias, then the matter distribution, expansion history, and perhaps even the observed balance between visible and invisible components could all have inherited it. That would not merely explain the voids. It would recast the entire cosmic narrative as the product of a subtle departure from the symmetry humans have always hoped for. We love symmetry because it feels like truth. The universe, however, may only use it sparingly and with ironic restraint. Around this time, one of the instrument specialists noticed that the void boundary appeared most sharply in data sets with the deepest exposure times, but not in the same way every time. In some reductions, the edge became smoother. In others, it sharpened into a contour that suggested a transition rather than a gradient. That dependence on processing should have pointed to a reduction artifact. Instead, the team realized that the boundary might not be a literal surface at all. It might be an observational threshold where the probability of structure formation, detection, or light propagation changes enough to leave an imprint. If so, then the void is less like an empty region and more like a boundary between regimes of cosmic behavior. That was a far more disturbing possibility. Boundaries imply hidden laws. The philosophical discomfort in the room deepened. A region of altered behavior means the universe may contain zones where the same physical constants are not equally expressed, or where the same constants lead to different observable consequences because the surrounding environment changes how they interact. The team began to wonder whether their own measurements were taking place in a privileged part of the cosmos, one where the rules happen to be legible enough for life to emerge and science to function, while other regions remain stable only in forms we cannot easily understand. That possibility did not sound dangerous at first, but it becomes dangerous when you realize it means knowledge may be local, not universal. The universe may not be one consistent explanation. It may be a patchwork of conditions that only look continuous from our narrow island of experience. The next step was to test whether the voids could be associated with a broader anisotropy in the Hubble flow. The study was delicate because small systematic biases in distance estimation can masquerade as directional variation. Yet once those were accounted for, a faint but persistent trend remained. Galaxies in the directions of the anomalies seemed to participate in slightly altered recession patterns compared to equivalent fields elsewhere. The effect was too minor for sensational claims but too coherent to dismiss. This was the kind of result that can rearrange a field over years, because once expansion is no longer treated as perfectly homogeneous, every large-scale inference must be revisited. The universe was not breaking in front of them. It was starting to feel uneven in its basic movement. One researcher described the sensation as trying to stand on a floor that appears flat until you realize the slope is not in the room, but in your sense of direction. That was exactly what the data were doing. They did not scream. They tilted. They turned confident abstractions into gradients. The cosmological principle, once a sturdy background assumption, began to feel less like an observed law and more like an approximation made from the viewpoint of a species too small to notice the deviations that matter. If the universe has preferred directions, local anomalies, or hidden domains of altered expansion, then our maps of it are not false, but partial in a much more serious sense than anyone likes to admit. Partial maps become dangerous when they are treated as complete. The deeper they looked, the more the void network seemed to interact with the notion of entropy itself, not in the simplistic sense of things get disorderly, but in the way systems approach equilibrium differently depending on their initial conditions and environment. In simulations tuned to the observed anomalies, entropy did not rise in a smooth universal march. It formed pockets, hesitations, and uneven transitions. Structure resisted dispersal in some regions, then collapsed into near emptiness in others. The voids behaved like places where the universe had not merely aged, but aged unevenly. That image was devastating because it suggested cosmic time may not be a single shared experience. Some regions may be moving toward heat death faster than others, or in ways that make the end state itself harder to define. Heat death has always been terrifying in an abstract, almost poetic way. The ultimate future in which energy is spread so thin that meaningful processes cease. But the anomaly gave it a different texture. It made entropy feel local, directional, and unevenly distributed. Perhaps the universe does not move toward a single static end. Perhaps some parts approach it early, while others delay, complicate, or escape the trajectory for longer than expected. The voids could then be seen as regional accelerants of cosmic exhaustion, places where the architecture of matter thins faster than the rest. Yet even that did not settle the case because some features around the void suggested organization rather than mere decay. The data kept oscillating between collapse and structure, between loss and arrangement, as if the cosmos could not decide which face to show. The team's private discussions became more guarded. They no longer argued simply about methods. They argued about language. What counts as an explanation when every explanation modifies the shape of the question? What counts as evidence when the evidence appears to depend on how long one looks? What counts as a void when the absence itself appears to have edges, memory, and directional influence? These were not rhetorical concerns. They were practical obstacles to interpretation. If the vocabulary of cosmology has no word for a region whose emptiness is dynamic, then the data may remain technically describable while conceptually unreachable. That may be the most frightening sort of failure, when a phenomenon is measurable but not yet thinkable. One night after the lab had emptied, the lead astronomer returned to the field images and turned off every unnecessary overlay. No annotations, no labels, no catalog numbers, just the raw stitched sky. Without the scaffolding, the void looked even more severe. The surrounding galaxies were not chaotic. They were ordered around the absence with a kind of architectural discipline. He stared at it long enough for the emotional meaning to change. At first it had been mystery, then unease. Now it felt like surveillance, not because he believed the void was alive in any ordinary sense, but because the pattern of its relation to everything else seemed too coherent to be passive. He shut the monitor, then opened it again immediately as if expecting the image to change while unobserved. It did not. That was somehow worse. The collaboration, desperate for another independent test, requested additional observations from a completely different telescope class, one optimized not for deep imaging but for high-resolution spectroscopy of faint background sources. The hope was to examine how the void influenced the absorption features of light passing near its boundary. If the region truly altered local conditions, then subtle shifts might appear in the spectra of distant quasars. Weeks later, the results arrived. There were shifts, tiny, but real. They suggested an oddity in the intervening medium, something not accounted for by the usual intergalactic gas models. The absorbers looked unusually sparse in some places and strangely organized in others, as if the medium itself had been arranged and then partially erased. The void was no longer just missing galaxies. It was missing structure in the space between galaxies too. That mattered because intergalactic space is where the universe spends most of its time. Stars are brief. Galaxies are elaborate but finite. The vast majority of existence is not solid, not glowing, not inhabited by familiar forms of matter. It is the in-between, the stretched dark where particles drift and fields linger. To find irregularity, there is to find irregularity in the default state of the cosmos. And if that default state is not uniform, then the simplicity we attribute to emptiness is an illusion. The voids may therefore be regions where the universe's background condition differs at a level beyond ordinary detection. The emptiness is not empty, it is modulated. The word modulated carried an uncanny resonance. It suggested signal. It suggested variation imposed on a carrier. That thought entered the room and stayed there. If empty space is modulated, then perhaps what we call vacuum is not the absence of content, but a field with structure we do not yet know how to perceive. Dark energy might be one expression of that structure, dark matter another. The voids could be locations where the modulation becomes visible because the ordinary clutter of galaxies and gas is missing. In that case, the anomaly would not be a violation of physics, but a revelation of an underlying layer. Yet the relief of that idea was short-lived, because a hidden layer is only reassuring until it starts behaving in ways we cannot model. The next contradiction came from time itself. Comparing fields observed years apart, the analyst found the void-related distortions had not remained constant in exactly the way expected. Not enough to claim temporal evolution in the obvious sense, but enough that the statistical residuals changed in a pattern that was difficult to blame on data quality alone. Structures at the edge of the void seemed to shift their inferred density slightly across epochs, as if the region's influence was not static. The likely explanations were mundane: differences in calibration, survey depth, or sample selection. But the coincidence of timing and pattern was too suggestive. If the anomaly evolves, then the void is not a snapshot of ancient structure. It is active in the present. That was the moment the lead theorist stopped speaking in metaphors and began speaking in warnings. An active anomaly means the cosmos is not merely carrying old scars. It may be generating new ones. The implications are immense. A static scar can be cataloged. An active one can spread. If the void's properties are changing, then the local universe may be experiencing a process with no easy endpoint. Some mechanism may be eroding structure, altering flow, or modifying expansion in ways that unfold on timescales too long to witness directly yet too short to dismiss as irrelevant. The idea felt like watching a cliff collapse so slowly that each grain of falling stone is individually unremarkable. Together, they change the landscape. The team began to speak with unusual care about the possibility of non-stationarity in cosmological observations. The word sounds sterile, but it hides a profound threat. Non-stationary behavior means the background itself changes over the course of measurement or across the scales where measurement is assumed to be comparable. If the universe is non-stationary on the largest scales we study, then our standard fits may be describing averages over conditions that do not actually persist. In that case, our most trusted cosmological parameters are not constants in the deep sense. They are summaries of a moving target. The voids made that possibility feel more than academic. They made it feel like the universe had begun to drift beneath the feet of its interpreters. Around this point, a younger member of the team confessed something that nobody had expected. She said the problem was no longer the data. The problem was that she had started to feel the universe was withholding not information, but composure. That phrase settled over the room with a strange gravity. Composure suggests not only order, but the ability to maintain order under observation. The universe had always seemed composed. Vast, yes. Indifferent, perhaps, but stable in its indifference. The anomaly suggested another possibility, that composure itself might be local, a property of certain regions and not others. The voids would then be places where the universe's composure fails, and where the underlying instability leaks through the surface of the observable. A few days later, the radio data produced the most disturbing hint yet. An otherwise unremarkable background source behind one of the voids showed a polarization pattern that could not be cleanly reconciled with standard foreground correction. The signal was faint and required extraordinary care to extract, but once extracted it pointed to a modest rotation in the plane of polarization that suggested unusual intervening structure. Again, the magnitude was not enough to warrant sensational claims, but the consistency of similar irregularities across distinct observations made the pattern hard to ignore. The void was influencing not just where light seemed to go, but how its orientation arrived to us. If that can happen without a massive visible structure, then whatever lies in the void's vicinity is operating at a level beyond ordinary astrophysical explanation. The team compared the polarization anomaly against possible magnetic field configurations, exotic plasma environments, and line-of-sight mixtures of known sources. None held up well. The region should have been too sparse for the effect to arise naturally, yet there it was. The result sent them back to an older, more unsettling hypothesis. Perhaps the void is a symptom of unknown coupling between cosmological fields. Not matter alone, not expansion alone, not background radiation alone, but some interaction among them that becomes apparent only in the absence of ordinary structure. The idea was technically defensible. It was also profoundly unhelpful, because every new coupling introduced another layer of complexity and another chance for the standard picture to fail. In the archives, they found older papers that now seemed almost prophetic in hindsight. Studies of low-variance regions in the cosmic background, debates over hemispherical asymmetry, puzzling reports of large-scale directional preferences, and unresolved hints that the universe might not be as statistically neutral as expected. None of those studies had been decisive alone, but together, in the shadow of the void network, they began to feel like fragments of a buried argument the cosmos had been making all along. The team did not say this in public, but privately, the sensation was hard to suppress. The present anomaly might be the visible crest of a much older wave of uncertainty, one that has been traveling through cosmology for decades without yet breaking fully. The emotional weight of that realization was strange. It did not feel like a dramatic revelation. It felt like recognition. That is often how dread works when it comes from evidence rather than fiction. You do not scream. You remember. A pattern that once seemed accidental begins to resemble the shape of your own assumptions cracking. A void that seemed isolated becomes the end point of older warnings. A discrepancy that seemed technical becomes philosophical. One of the senior observers admitted, almost in passing, that for the first time in his career, he was not sure whether the question was what the universe is made of, or what kind of behavior the universe is capable of under observation. That difference, however subtle, changed everything. Because if the cosmos is capable of different behaviors depending on how it is examined, then the observer is part of the phenomenon in a way far more profound than simple measurement error. Quantum mechanics has long made people comfortable with that idea at small scales, but no one wanted to see its echo in the architecture of galaxies. Yet the voids seem to suggest exactly that, an observational dependence so large that it blurred the distinction between description and participation. The act of looking might not create the void, but it might help determine which of its traits become visible. And if that is true on the scale of millions of light years, then the universe may be more relational than mechanical. That thought carries a kind of quiet horror, because it means reality may not stand apart from inquiry. It may meet inquiry halfway, but not honestly. That night, the lead astronomer stood before the live data feed as the telescope continued to gather light from somewhere beyond the reach of any human map. The screen showed a web of distant galaxies, each one a point of delayed history, and the voids between them opened like dark doors. He thought about entropy. He thought about expansion. He thought about the fact that every star in the field was headed toward an end, every galaxy toward isolation, every observable thing toward a future in which its energy would disperse into the cold. And yet the data suggested that the journey itself may not be smooth or uniform. Some regions may decay faster. Some may warp the route. Some may not obey the same decline. That realization was the final theft of comfort. Even the universe's long unraveling may not be as simple as extinction. It may be uneven, patterned, and full of local exceptions that we do not yet know how to name. The cosmos outside remained silent, but the silence had changed character. It no longer felt like indifference. It felt like withholding. The researchers were starting to understand that their deepest problem was not the void itself, but the possibility that the void is a threshold into a class of phenomena where the methods of modern physics are only partially applicable. That possibility spread through the team with the slow force of cold water under a door. It meant their best equations might still be correct and still be insufficient. It meant the universe might hold together in ways that are stable only at certain levels of description. And it meant that beneath the beautiful regularity of the night sky may lie a more unstable reality, one that does not simply await discovery, but resists being fully made coherent. The final set of observations was prepared in near silence. No one spoke loudly. No one joked. The next data window would be pointed toward a region adjacent to the alignment axis where the anomalies had first begun to cluster. There was no reason, strictly speaking, to expect anything catastrophic, but the feeling in the room was unmistakable. The voids had moved from curiosity to consequence. Whatever they were no longer contained by the language of unusual density or unusual expansion. They had become evidence that the universe may operate with degrees of freedom not captured by current cosmology. In the dim light of the control room, with the galaxy maps spread across the screens like constellations of a troubled mind, the team waited for the sky to answer again, and for the first time they were no longer sure they wanted to hear what it had been trying to say. The final observing run began with a weather report so clear it felt almost ceremonial. No haze, no moisture, no interference from the atmosphere. The telescope would have the sky in its purest accessible form, and that purity only made the tension worse. In the control room, every screen glowed with a quiet clinical light. The team watched the acquisition sequence lock onto the target field, and when the first deep exposures began to stack, nobody looked away. They had spent too long learning that the universe tended to answer most sharply when given time. So they waited, not with optimism, but with the vigilance of people standing beside something whose behavior they no longer trusted. The preliminary frames looked ordinary enough to make the room exhale. A scattering of faint galaxies, a few foreground stars, a low background of noise that could still be explained in the language of statistics. Then the composite built up, and the familiar geometry emerged again, but now with a severity that made the earlier version seem almost gentle. The void network was more defined, the boundaries sharpened, the directional alignment across the anomalous regions became unmistakable, and just when the data should have settled into a predictable fit, A new feature appeared at the edge of the frame, a subtle curvature in the background distribution, as if the larger sky itself had been drawn inward around the gap. It was not a visual trick, it was in the numbers. One of the analysts checked the pointing solution twice, then a third time, then a fourth, refusing to accept what the screen was suggesting. The field had not shifted. The coordinate system was stable. The anomaly was not a byproduct of misalignment. That left only the region itself, and the room fell into the kind of silence that follows the failure of the last ordinary excuse. The void was not simply present. It was exerting a measurable influence on the surrounding observational geometry. In the language of physics, that meant something was wrong with the local description of space-time, or the assumptions used to infer it. In the language of the body, it meant everyone had begun to feel the same involuntary tightening in the chest. The team pushed the data through an alternate pipeline in real time, stripping away every procedural layer they could think of. The result remained. A second independent team working from a remote archive copy of the raw frames reproduced the same contour. That was the moment when the room stopped hoping for a software bug. The anomaly was now robust enough to resist skepticism without becoming less frightening. It meant the sky was not merely being poorly read. It meant the sky itself was presenting a shape that current cosmology had not prepared them to integrate. But the real problem was only beginning. Because if the void's influence extended into the geometry of observation, then the thing they were seeing might be changing the act of seeing. The phrase sounded abstract until they mapped the region against successive exposures. A tiny but persistent drift emerged in the inferred positions of sources near the boundary, too small for casual notice, too systematic to ignore. It was as though the local reference frame had acquired a fractional instability. The effect did not behave like a simple lensing distortion, and it was not consistent with ordinary proper motion. It was subtler, more invasive. The sky was not moving exactly. The sky was making the act of locating things inside it slightly more difficult. That distinction was devastating, because if the universe can interfere with positional certainty at this scale, then the ground rules of astronomy are not merely challenged, they are exposed as provisional conveniences. A theorist suggested a topology issue, a folding of spacetime on scales too vast for conventional intuition. Another proposed that a hidden mass distribution might still be responsible, perhaps arranged in a configuration unusual enough to create the observed geometric tension without leaving a clear luminous trace. A third floated the possibility of a coupling between dark matter and a variable dark energy field, one strong enough to alter local expansion gradients. Each idea was plausible in pieces. None survived contact with the whole, and every time an explanation was refined, it seemed to reveal a second-order effect no one had anticipated. The void was not just an absence in a map. It was a test of how much distortion the universe can generate before our language loses the ability to keep pace. The scientists began to notice that the anomalies clustered most strongly in regions where observational certainty depended on multiple indirect inferences stacked atop one another. Distance from redshift, mass from lensing, density from counts, expansion from calibration. Every step in deep space astronomy requires some faith in the chain. The void seemed to strain that chain by introducing a bias at each stage, small enough to evade immediate detection, cumulative enough to alter conclusions. It was a terrifyingly elegant mechanism, not because anyone believed it was intentional, but because it exploited the architecture of knowledge itself. The deeper they looked, the more the universe seemed to prefer situations where certainty must be assembled from many fragile assumptions. And fragility, once noticed, has a way of spreading. On the archival tables, printouts from earlier cosmological surveys lay half-folded beneath newer reports. The room had the look of a place where many generations of confidence had been spread out and quietly undermined. One of the senior researchers traced a finger across a plot of the Hubble residuals and then over the void map, pausing where the strange structures crossed one another. The overlap was not exact, but it was too suggestive to dismiss. If the local expansion rate had been biased by the environment, then the void network might be part of the reason cosmologists have long disagreed about the universe's measured pace. That would not only make the anomaly larger, it would make it foundational. A clue about one strange region of sky could alter the way the whole cosmos is timed, but it goes deeper than a disagreement about timing. If the expansion history is locally perturbed, then every age estimate, every distance ladder, every claim about the chronology of cosmic structure becomes vulnerable to revision. The apparent age of the universe might still be roughly correct in broad strokes, but the route by which we reach that number may be laced with unseen dependencies. That realization placed the voids beside one of cosmology's most persistent tensions, the mismatch between early universe and late universe measurements. What had once looked like a technical inconsistency began to feel like a symptom of a more general instability. The anomaly was not isolated anymore. It was sitting inside a wider wound in the field, and the wound had not closed. To test that possibility, the team compared the void's location against independent measurements of peculiar velocity, cosmic shear, and galaxy cluster dynamics from unrelated surveys. The results were maddeningly consistent in their inconsistency. Small deviations accumulated in the same direction. Large structures nearby appeared to follow flows that bent around the region as if drawn past a hidden pressure. Not a clean gravitational attractor, not a clean empty basin, something in between, something that could not be reduced to mass alone. The numbers suggested a local anisotropy in how matter and expansion interact, but the scale and coherence of the effect resisted a simple classification. The universe was not giving them an object, it was giving them a behavior. Behaviors are harder to pin down than objects because they can recur without repeating exactly. That is what made the growing pattern so unnerving. No single field or wavelength held the whole truth, yet each new line of evidence echoed the others. In radio, in infrared, in optical counts, in lensing residuals, in expansion fits, the same faint tilt appeared, the same refusal of symmetry, the same suggestion that the cosmos was less uniform than the underlying theory assumes. The team began to wonder whether the voids were where the universe's hidden complexity leaks into visibility. If so, then emptiness is not a blank state. It is a revelation state. It shows us the edges of what ordinary structure can conceal. Outside the observatory, the world still functioned in the old way. People slept, traffic moved, weather changed, cities glowed under humid skies. None of that was touched by the data, yet the scientists felt an almost guilty separation from ordinary life, as if they had crossed into a mental altitude where every casual assumption felt less secure. The voids had changed the scale of their attention. A streetlight now seemed small in a different way. A star seemed lonelier. A galaxy cluster seemed less like an impressive accumulation of matter than a brief and fragile exception to the rule of near-nothingness. The universe had always been mostly empty. Now the emptiness felt organized. The organization became harder to ignore when the team revisited entropy models for the local region. If a void develops through ordinary structure formation, then the surrounding matter should show predictable thermal and dynamical signatures. But here the signatures appeared scrambled. Some areas near the boundary looked as if they had cooled and dispersed too efficiently. Other adjacent patches retained coherent flows longer than expected. That asymmetry suggested the local approach to equilibrium was not uniform. In a universe already drifting toward heat death, the void network seemed to produce regional accelerations and delays in the same grand process. That is a deeply uncomfortable thought because it implies cosmic decline is not a single slope. It may be a landscape with ravines, ledges, and hidden descents. One of the younger scientists quietly asked whether the voids could be acting as entropy sinks. The room stared at him. The idea was not impossible in the abstract, but its consequences were difficult to hold. An entropy sink would mean that the local environment is not merely sparse, but able to channel disorder in a way that changes the surrounding thermodynamic fate. That would be extraordinary on scales like this, and it would require physics far beyond the standard catalog. Yet the data did not dismiss the idea. In fact, some of the thermal gradients around the void edges looked suspiciously like the aftermath of a process more organized than collapse alone. If the voids are swallowing disorder differently, then the cosmos may contain pockets where the usual arrow of time behaves with local irregularity. The room went very still after that. There are sentences that sound speculative until you realize they imply a revision to the structure of reality. Local irregularity in the arrow of time was one of them. Not time travel, not science fiction theatrics, but the possibility that the practical thermodynamic direction of events could differ subtly across regions of space. If that were true, the universe would not only be uneven in matter distribution and expansion, it would be uneven in how it ages. The voids might then be seen as places where cosmic history thins faster, where the future arrives in a different form, or where the road toward equilibrium is warped enough to leave observational scars. The scientists did not have a name for this. That was part of the horror. In a desperate effort to restore footing, the theorists returned to standard alternatives: hidden clusters, statistical flukes, line-of-sight contamination, unrecognized foreground objects, exotic but localized gas distributions, and catalog incompleteness. Each theory was checked, then checked again. Each fell short in some crucial way. The void network was too coherent to be noise and too sparse to be a normal mass structure. Its relationship to the background sky was too aligned to be accidental, but too diffuse to be a conventional source. It existed in the same ambiguous territory as a rumor that has been verified by too many witnesses to dismiss, yet never captured in the act. The team began to understand why the anomaly had become so emotionally corrosive. It was impossible to accuse the universe of lying without also admitting it may be telling the truth in a form we cannot parse. The next batch of data came from a deep cluster survey aimed far beyond the original target field. The scientists were trying to learn whether the void-aligned structures extended into a supercluster environment. They did. Not neatly, not continuously, but enough to reveal a startling tendency. The largest galaxy assemblies near the void network appeared subtly arranged along the same preferred orientation. This was not a local accident. It was a cosmic trend. Filaments bent around sparse regions. Clusters gathered where the void influence was weaker. The large-scale web of matter looked less like a random network and more like a response pattern, as if the universe had been pressed in one direction, and the resulting structure remembered the force. A response pattern implies a stimulus, and that is where the conversation became almost unbearable. What stimulus could act across such distances and timescales? A primordial perturbation? A hidden field? A non-standard cosmological phase transition? Or something outside the standard categories entirely? Some aspect of the universe that our models have only felt as residuals and asymmetries. The answer was not coming from the maps. Instead, the maps were forcing the question to sharpen. The voids, the alignments, the distortions, the shifts in expansion, the lensing anomalies, the entropy irregularities, all of them together suggested not a single broken measurement, but a hidden variable in the cosmic system. If that variable exists, then reality is more elaborate than our current physics. And that leads to something more disturbing. Perhaps reality is not just more elaborate, but more unstable. Because a hidden variable that influences structure, expansion, and observational certainty across vast scales is not a passive ingredient. It is a potential source of unpredictability. The team began to see that the void network may not simply reveal incompleteness in our theory. It may reveal that the universe itself is not bound to remain within the same descriptive regime everywhere and forever. That is an unnerving thought, because it removes the comfort of universal sameness. The laws may not be broken, they may be conditional, and if the conditions vary without warning, then science is not studying a single static order. It is navigating a landscape with invisible weather. During one late session, the lead astronomer reviewed the void maps at the highest available resolution and felt a sudden, irrational certainty that he was looking at a boundary rather than a center, not the boundary of the region, but of the model. The anomaly had been treated as though it occupied space, but what if it occupies a transition between behaviors? In the same way an ocean front marks the place where one medium yields to another, the void might mark where one kind of cosmic rule becomes another, or where our observational language stops being adequate. That idea did not feel like triumph. It felt like stepping up to a glass wall that had been mistaken for open air. The universe was still there. The route to understanding it might not be. The team requested one final round of combined wavelength integration, this time including the latest optical deep fields, infrared mosaics, radio background maps, gravitational lens reconstructions, and local expansion residuals. When assembled into a single comparative display, the result was so unsettling that nobody spoke for several minutes. The voids were not identical across the datasets, but their relationships were too coordinated to ignore. The same broad contours repeated at different scales, the same directional slant, the same failures of symmetry. It looked as though multiple observational windows were not merely seeing the same place differently, but detecting different layers of the same underlying discrepancy. The room felt less like a laboratory and more like a witness stand. One of the data scientists whispered that the anomaly behaved like a system trying to remain invisible while still producing consequences. The sentence landed hard because it sounded too close to the truth. If there is a structure in the cosmos that affects matter, light, expansion, and entropy, yet only manifests as a pattern of absences and distortions, then detection itself becomes indirect by necessity. That may be why the answer has remained out of reach, not because the universe is silent, but because it speaks through omissions. The voids, then, are not emptiness in the ordinary sense. They are traces of whatever the universe is doing when it leaves behind less than expected. The philosophical consequences of that thought spread quickly. A universe that leaves traces in absence is a universe whose deepest behaviors may be legible only at the margins of what is there. Human understanding has always preferred positive evidence, luminous objects, clean lines, signals that can be extracted and named. But the voids taught the team that what is omitted may carry as much information as what is present. That is a difficult lesson to absorb because it means the tools of certainty are designed around the wrong polarity. We look for things. The cosmos may be revealing itself through lack, delay, and withdrawal. In that sense, the mystery was becoming more than scientific. It was becoming ontological. As the night wore on, fatigue sharpened everyone's perception. The screens seemed brighter, the silence deeper, the black between stars more pronounced. They were all aware that they had entered the strange phase of a long investigation in which the questions become more frightening than the results. A result can be filed, debated, revised. A question that changes the nature of reality's stability does not sit still. It follows you home. It takes shape in reflections and afterimages. It makes ordinary darkness feel less innocent. The voids had not yet revealed what they were, but they had already changed the universe's emotional texture. That, too, was data. The final consult of the cycle came from a colleague who had been monitoring the evolution of standard cosmological fits over the last few months. She pointed out that if the void-related discrepancies were introduced as a localized perturbation to the model, the surrounding parameter space became unexpectedly unstable. Tiny shifts in assumed density or expansion history caused broader fits to branch wildly. The universe, in that sector of sky, appeared to be perched near a threshold where small changes would trigger large interpretive consequences. That is not supposed to happen in a well-behaved cosmological model, but it was happening. And because it was happening in more than one observational domain, it began to feel less like a numerical nuisance and more like a warning from the structure of the cosmos itself. The lead astronomer looked again at the composite and felt the old boundary between wonder and dread dissolve completely. What they had found was not a hole, not even a wound. It was a region where the idea of a hole failed to capture the behavior, where absence had become active, where darkness carried geometry, where the sky seemed to organize itself around something invisible that remained just outside the reach of direct proof. He understood then that the anomaly's greatest power was not in what it might be made of, but in how it made the whole enterprise of cosmic certainty wobble. If the universe can conceal this much inside emptiness, then every model built on the assumption of transparency stands on uncertain ground. They waited for the next exposure to finish stacking. The room was tense with the kind of anticipation that borders on dread. Outside, the observatory was still a small, warm island in a cold mountain ocean. Above it, the universe continued to expand with patient indifference, galaxies drifting apart across distances no human will ever cross. But on the screens, the voids held their shape and their secret. The final composite sharpened, and at the far edge of one of the aligned regions, a new irregularity appeared. An asymmetry so slight that any earlier stage of the project would have ignored it, but now it stood out like a crack in glass under moonlight. The team leaned closer. It was not a new void. It was something worse, a faint indication that the boundary itself was changing in response to their observation. No one spoke at first. Then someone very quietly asked whether the universe could be reacting to the accumulation of information about it. The question was not answered, because no answer felt sufficiently stable to survive the room. If the anomaly is responsive, then the act of measuring has entered the phenomenon in a way that is not merely statistical. If it is not responsive, then the boundary change must have another explanation, one that is still hidden inside the growing body of contradictions. Either way, the feeling that settled over the team was unmistakable. They were no longer looking at a mystery contained in the cosmos. They were looking at a cosmos whose behavior might not be fully separable from the terms under which it is observed. And that is the point where the final implication begins to emerge. If reality changes its apparent structure at the edge of observation, then human knowledge does not simply lag behind reality. It may participate in shaping the very regularities it seeks to describe. On the smallest scales, physics already whispers that truth. Here in the dark between galaxies, it was becoming loud enough to shake cosmology. The voids had taken the question from matter to motion, from motion to expansion, from expansion to entropy, and from entropy to the stability of the laws themselves. The deeper they looked, the less the universe resembled a passive object, and the more it resembled a system whose deepest properties are still deciding how to be known. The final frame of the night held steady on the composite sky, and the team could feel with increasing certainty that they had not reached the edge of the mystery. They had reached the edge of the framework. Beyond it, perhaps, lay a version of the universe that is not consistent with our cleanest equations, not because those equations are useless, but because they were built for a reality only partially visible from here. The observatory remained bright. The stars remained silent. The voids remained. But the feeling in the room was no longer simply that something was hidden. It was that the universe may be larger, stranger, and less reliably comprehensible than the structures of science have prepared us to believe. And in that realization, there was no comfort at all. Only the long, cold implication that reality itself may not be as stable as the act of looking has always assumed. By dawn, nobody in the observatory had slept. They sat with the consequences of the last composite image like a verdict they could not appeal. The sky outside began to pale, but the data room stayed sealed in its artificial darkness, screens still glowing with the final frame. The void boundary had changed. Not much, not in a dramatic motion visible to the eye, but enough to show that the anomaly was not fixed. It had adjusted after the longest continuous observation yet attempted. The implication settled slowly, with all the weight of something that could not be unlearned. If the boundary shifts in response to sustained measurement, then the void is not simply there. It is doing something with the fact that it has been seen. The first reaction was denial, and the second was procedure. They verified timestamps, revisited calibration logs, checked detector stability, and compared the result against the remote archive. Everything held. The change was real. It had happened within the observation window, and no known instrumental drift explained it. One of the engineers suggested a thermal fluctuation in the detector chain. Another pointed to subtle seeing changes. A third proposed a processing artifact linked to long exposure stacking. Each explanation was tested against the record and found wanting. The room was left with the disturbing possibility that the void structure was not simply being revealed by observation, but altered by it in some way they had not predicted. That possibility split the team into camps almost instantly. Some argued that the effect must still be mundane, a complex observational bias that only looked reactive because the dataset was dense enough to make the noise appear intentional. Others, less willing to comfort themselves, insisted that the phenomenon demanded a new category of explanation. Neither side had the luxury of certainty. The evidence was too strong to dismiss and too strange to absorb. The lead astronomer listened to both sides without speaking. He knew that once an anomaly begins to look adaptive, the problem stops being just physical. It becomes methodological, and once the methods fail, the whole discipline starts to shake. The next experiment was brutally simple. They would observe the same region again, but with a different cadence, a different reduction chain, and a different instrument group entirely removed from the original analysis. If the boundary changed again, then the effect could not be confined to one workflow. The hours that followed were slow and tight with apprehension. When the new frames arrived, the answer came in a form so quiet it nearly escaped notice. The contour had shifted once more, slightly, consistently, toward the same alignment axis that had haunted the previous maps. A pattern had emerged from the pattern, and with it came the awful realization that the void was not merely changing. It was changing in a direction. The word direction made everyone uneasy, because direction implies intention whether one wants it to or not. Yet no one in the room seriously believed they were witnessing intention in any human sense. What they were seeing was more likely a system with stable rules that had not been recognized yet, but even that did not soften the pressure of the moment. A directional change means the phenomenon has an orientation in state space, as though the anomaly is moving toward a configuration that matters more than the others. In the language of cosmology, that could mean a transition, a phase boundary, an evolving field. In the language of fear, it meant the void was no longer passive. It was becoming. They expanded the analysis to include not just spatial alignment, but the temporal evolution of neighboring structures. Galaxy counts near the boundary had altered by fractions too small to be obvious and too consistent to ignore. A few distant sources appeared slightly displaced in the latest fit, though not enough to suggest motion on human timescales. The team cross-checked with archival exposures from years earlier, then reconstructed a course trajectory of the measured discrepancies. The result was not a clean curve. It was a set of small deviations all leaning the same way, as if the region's influence had gradually intensified. If true, the void was not a static feature embedded in the universe. It was an event unfolding across astronomical time. That notion changed the emotional tenor of everything that followed. A static anomaly can be endured. An evolving one cannot. It implies a future. It implies that the state of the sky in this region may be different a year from now, or a decade, or a million years into the cosmic record. This was especially unsettling because cosmic events are usually so slow that they feel eternal. Here, however, The void appeared to possess an internal tempo, distinct from the broader universe. The team started to ask whether the phenomenon was localized in space only, or in both space and time. If the latter, then the problem might not be a hole in matter. It might be a moving discontinuity in the way matter and space-time interact. The theorists were forced back into the oldest and most uncomfortable territory: phase transitions in the early universe. The language of cosmology has always had room for sudden changes: inflation, reheating, symmetry breaking, vacuum selection. Transition states leave traces. They can shape later structure in ways that survive long after the initial event has faded. If the void network were a relic of such a transition, it could account for the directional alignments, the entropy irregularities, and the odd interplay with expansion. But no ordinary phase transition should continue to evolve like this on accessible timescales. That meant if a transition was involved, it might be one that has not finished. The universe may still be crossing it. No one liked that idea. It made the cosmos feel unfinished. Not metaphorically unfinished, but physically unresolved, as though the state of reality we inhabit is only one segment of a much larger process. The room was quiet while they considered the possibility that the observable universe might not be a settled structure, but a transitional environment. The voids could then be sites where the transition is more visible, where the old and new states of cosmic behavior meet and leave scars. This fit the data better than most options, but it came with its own terror. If the universe is still transitioning, then the stability we rely on is temporary in a way that no one can estimate. A junior researcher asked whether the changing boundary could be the front edge of a propagating effect. The question was met with instant attention, because it was the first to give the shape a motion that did not feel purely metaphorical. A propagating effect would imply the void is not one thing, but the visible front of something larger, spreading through a cosmological medium. It could be a region of altered field dynamics, an expanding patch of vacuum state, or a wave of reduced clustering moving through structure formation. The idea was speculative, yes, but it matched the directional shift and the temporal drift. If correct, the anomaly was not just present, it was advancing. The possibility of advancement changed the room in an instant. The word conjured images no one wanted to own. Not invasion, not in the cinematic sense, but a process that moves outward and reorganizes what it encounters. A wave in cosmology is not usually feared because most waves disperse. But if the wave concerns the state of space-time or the local behavior of dark energy, then dispersal may not be the relevant outcome. The team ran the appropriate tests, trying to detect any sign of increasing influence in adjacent fields. The signal was faint but troubling. Several peripheral regions now showed subtle statistical shifts that were absent in earlier surveys. The void's shadow seemed to be widening. By this point, the collaboration was functioning under a shared strain that bordered on discipline and obsession. Meals were neglected. Phone calls went unanswered. The observatory lost its distinction between day and night. Every discussion circled the same problem from a different angle, and every angle pointed back to the same stubborn core. The anomaly was too coherent to be random, too diffuse to be obvious, and now too dynamic to be treated as a frozen artifact. The usual vocabulary of cosmology had started to feel inadequate in the same way a ruler feels inadequate when the thing being measured keeps changing shape. They were still scientists, but they were also, increasingly, witnesses to a failure of categories. Some of the younger staff began comparing the region to a kind of cosmological weather system, one with pressure gradients and fronts. It was only a loose analogy, but it helped them talk about something otherwise too abstract to hold in the mind. The void as weather suggested motion without agency, structure without intent, change without a single cause. Yet even that analogy had limits. Weather dissipates. This did not. The pattern extended across independent data sets and persisted under different assumptions. It was atmospheric in feeling but fundamental in consequence. The void did not behave like a storm. It behaved like a climate of absence, slowly reorganizing the conditions under which the universe becomes visible. The phrase, climate of absence, struck one of the theorists so deeply that he repeated it later in a separate meeting. It captured the problem better than anyone had expected. There are regions of the cosmos where matter is sparse by comparison, but this was something else. A climate is not a thing, it is a regime, a persistent state in which many local variations can occur while still following a broader pattern. If the void network is a climate, then it could explain why the anomalies appear in related forms across great distances without being identical. It would mean the universe contains zones with similar conditions of emptiness and distortion, and that those zones may influence how structure arises over long spans of time. But once they embraced the word climate, Another unsettling implication followed. Climates can shift, slowly, sometimes dangerously, but they do shift, and when they do, the consequences propagate far beyond the region where the shift begins. That sent the team back to the edge behavior. Was the void boundary moving because the climate was changing, or was the climate changing because the boundary was moving? The answer could not be separated cleanly from the data. The distinction itself had begun to blur. The phenomenon was not simply observed at a distance, it was observed through its interaction with the tools that described it. The universe was turning their own methods into part of the story. One of the most experienced instrumentalists finally spoke up and admitted the obvious. If the anomaly is reacting to observation, then the next question is whether we are observing it, or whether it is sampling us through the constraints of our methods. He said it in a low voice, half joking and fully not joking. No one responded immediately because no one wanted to make the sentence more real by answering it. In practical terms, what he meant was that the act of repeated, high-depth observation might be selecting for a regime in which the void's reactive behavior becomes visible. That would not require consciousness on the void's part. It would only require the system to have a threshold. Still, thresholds can be terrifying when the stakes are cosmological. The group spent the next several hours trying to identify any threshold-like behavior in the data. They varied exposure time, field size, and processing depth. In some cases, the anomaly remained stable. In others, the boundary sharpened after a certain observational density was reached. That was not enough to claim causation, but it was enough to imply the possibility of a regime change in the observability itself, as if there were a level of scrutiny beyond which the structure could no longer remain in its earlier form. This concept sat uneasily in the room because it suggested a limit not only to current telescopes, but to the compatibility between deep observation and stable inference. The deeper one looks, the less the sky may resemble what it looked like before. The idea of compatibility led them back to the question of fundamental constants. If the anomaly marks a region where local vacuum properties differ, then physical constants may not be universal in the strictest sense. Most of physics tolerates tiny variation only under tightly constrained circumstances, but the void's behavior kept refusing to fit the same box twice. Its influence on lensing, expansion, and background light all hinted at some deeper parameter change. Not enough to produce dramatic violations, but enough to accumulate into a coherent offset. That would mean the universe is not governed by a single, fully uniform set of conditions. Rather, it may express its laws through a landscape of slightly different states, with the voids marking transitions between them. The landscape metaphor was attractive until it started becoming literal in everyone's mind. If there are different states of the vacuum or space-time across the cosmos, then the void network could trace the contours of a larger field of reality. The team had no evidence of such a field, only its shadows. But shadows are often all one gets in deep cosmology. They revisited the idea of vacuum metastability, this time with greater seriousness. If the local universe is in a metastable state, and the voids reflect regions where the transition dynamics differ slightly, then the boundary shifts could be the signature of a process moving through the cosmic medium. The possibility was elegant enough to be dangerous. It made the voids look like fronts in a much larger physical transition, yet even that explanation did not account for the alignment between the voids and the early universe background asymmetry. Something older still had to be involved. Either the primordial conditions seeded a directional susceptibility, or the cosmos has a hidden axis that only becomes visible when structure grows sparse enough to expose it. The team measured and remeasured the orientation with obsessive care. The alignment persisted. It was not perfect, but it was too meaningful to ignore. A hidden axis is one of the most disconcerting ideas in cosmology because it violates the comforting expectation that, on large scales, no direction is privileged. If the universe has one, then our place within it may be far less generic than assumed. Generic is a word humans like in cosmology because it spares us the burden of significance. We are not at the center. No special direction, no preferred location, just one outcome among many in a broad and even expanse. The voids made that story feel brittle, not false exactly, but overconfident. If there is a directional structure in the sky, then the apparent neutrality of our vantage point may be an accident of scale. The observatory, perched on its mountain, began to feel less like a window and more like a needle pressed against a membrane. On the other side of that membrane, the universe was not necessarily watching, but it was certainly not as simple as the textbooks had promised. The project's external reviewers requested a full technical summary. The team delayed twice before sending it, then stripped the language of all speculative claims and sent only what could be defended line by line. Even so, the summary read like the outline of a problem too large to contain in professional prose. Unusual large-scale underdensities, aligned void geometries, weak but persistent anomalies in lensing, background anisotropy, and local expansion estimates, temporal evolution of boundary contours, no consensus model. Every sentence was sober. Every sentence was alarming. The reviewers responded with cautious interest as expected, but also with the kind of restraint that often appears when a field suspects it is standing near an interpretive cliff. The lead astronomer could not shake the feeling that they had reached the point where the universe had ceased being an external object and become a test of the limits of comprehension itself. That sensation did not come from any single measurement. It came from the cumulative pressure of the evidence, from the way each answer pushed the question outward rather than closing it. The voids had taught them that absence can be structurally active, that structure can be unstable, and that the rules governing large-scale reality may not be as static as assumed. But the deepest wound was this. The sky had not broken in a way that made it easy to accuse. It had broken in a way that made the old confidence feel naive. The next observation cycle began anyway, because science does not stop when it becomes uncomfortable. It continues, often in the hope that repetition will restore order. But order did not return. The first deep frame came back with the void boundary already shifted by an amount too small to dramatize and too large to ignore. The second frame confirmed it. The third framed it as motion. The fourth made the motion look coordinated with the aligned axis of the broader anomaly field. At that point, the room changed from analysis to alarm. Not panic, not yet. Something colder. The awareness that they were no longer documenting a fixed phenomenon, but tracking a process they did not understand and could not fully bracket. The lead astronomer stared at the final stacked image and felt an almost physical certainty that the universe had grown more conditional. Not necessarily less real, not less lawful, but conditional. Boundaries, effects, and observations now seemed to depend on context in a far deeper sense than the team had originally imagined. The voids had become a demonstration that even the largest scales may be governed by circumstances we cannot yet see. The room around him remained unchanged. Cables, monitors, coffee cups, dark glass, the faint mechanical pulse of equipment, but the sky represented on those screens had become irrevocably harder to trust. And as the dawn light crept across the observatory windows, the most disturbing thought of all settled in quietly. If the universe can alter the meaning of emptiness, then there may be no region of reality left where certainty can rest for long. The last morning at the observatory arrived without ceremony. No alarms, no storms, no dramatic instrument failure, just pale light across the ridge and a room full of people who no longer knew exactly what they were waiting for. The void remained on the screens, held inside layered false color and stubborn numbers, and the most unsettling part was that it looked calmer than the team felt. The boundary had shifted again during the night, by an amount so slight that only the cumulative record made it undeniable. It was no longer possible to say the phenomenon was merely being observed. It was now behaving across the span of observation itself, and that made every previous assumption feel like a temporary convenience. They performed one last round of verification, not because they expected a different answer, but because procedure offers a kind of moral shelter when certainty collapses. The calibration checks returned clean. The control fields remained normal. The independent archive confirmed the same contour changes. The void network was still there, still aligned, still subtly evolving. A silence settled over the team that was less about shock than about exhaustion. They had crossed through disbelief into something more difficult to name. The state that follows when a mystery has become a condition of life rather than an event to solve. No one spoke about publishing yet. No one mentioned press releases, conference talks, or next steps. Those belonged to a world where the universe still behaved like a problem with an endpoint. The lead astronomer broke the silence first. He asked whether anyone had noticed that the anomaly seemed less like a thing and more like a limit. The sentence hung in the room because it clarified what all of them had been circling for days. The void was not simply an underdensity, not simply a structural oddity, not simply a sign of unusual expansion. It was behaving like a place where the assumptions behind observation thinned out, a boundary between regimes, a place where matter, geometry, and inference were no longer fully separable. The room accepted that idea the way people accept a diagnosis they never wanted, with grim relief, because at least the shape of the problem was becoming coherent enough to fear properly. Yet coherence did not bring comfort. If the voids marked transitions between regimes, then the universe was not merely more complicated than the standard models. It was layered in a way that had practical consequences for what could be known, and possibly for what could be stable. One theorist laid out the implications as plainly as he could. If local vacuum properties differ, then the effective laws governing structure formation may vary by region. If the voids are evolving fronts, then whatever state lies beyond them might be spreading. If the observed directional alignments are real, then the larger cosmos is not isotropic in the way current frameworks assume. Each statement was simple. Together they formed a picture too vast to fit into any comfortable category. The universe had become less like a stage and more like a gradient. Someone asked the question nobody wanted to ask. What if the gradient is not only spatial? No one answered immediately because everyone understood the deeper implication. If the phenomenon has temporal structure, if it changes with continued observation, if its boundary moves, then the voids may be tied to a process that unfolds through both space and time, a process that could alter the conditions under which matter arranges itself, a process that might not stop. That possibility made even the most hardened researchers quiet, not because it was sensational, but because it was plausible enough to be dangerous. A static cosmological oddity can be studied. A process with an unknown endpoint is something else. It forces the mind to confront the possibility of transformation without a known limit. The external reviewers finally called back. Their tone was measured, professional, and unmistakably cautious. They had run partial checks against their own independent datasets and found hints, though not yet claims, of similar large-scale discontinuities in other survey regions. Nothing definitive, nothing publishable on its own, but enough to suggest the team's anomaly was not a local mistake. The call ended with polite restraint, yet it left the room chilled. If other groups were starting to see echoes of the same pattern, then the problem was no longer isolated to one field or one observatory. It had begun to seep into the broader evidence base, where multiple instruments and multiple teams would eventually have to confront it. The voids were starting to leave the safety of obscurity. That realization changed the tone of the final discussion. It was no longer about whether the anomaly was real. It was about what category of real it belonged to. The researchers tried to name possibilities, and each name only highlighted a missing piece. Astrophysical structure was too small a frame. Vacuum dynamics was too abstract unless tied to data. Observational bias was too weak to explain the multi-wavelength coherence. New physics was accurate but vague. A transition front in the cosmic medium came closest, but still not close enough. The failure was not just explanatory, it was linguistic. The terms available to them could describe the pieces, but not the way the pieces were behaving together. Their vocabulary was outpaced by the pattern. The lead astronomer returned once more to the original discovery images, now with the burden of everything that had followed them. He noticed something he had not allowed himself to dwell on before. The void did not look hollow in the ordinary sense. It looked selective. The surrounding structures framed it too carefully, as if the absence had a contour determined by relationships with the matter around it. That made the region feel less like a missing patch and more like an actively maintained condition. He zoomed in and watched the boundary pixels sharpen under the processing filters. The edge seemed to hesitate, then settle, as though the representation itself were being nudged into a new equilibrium. He felt a sudden, irrational certainty that the sky was not merely being measured, it was tolerating the measurement. That thought was enough to unsettle him, but not enough to stop him from asking the next question. If the void tolerates measurement, what happens when the measurement grows intense enough to alter the terms of that tolerance? The team decided to test the highest resolution data one final time against the same region, but now with every redundancy they had, multiple pipelines, multiple calibrations, multiple independent reductions. The result was consistent and worse than before. A faint but unmistakable shift had appeared in the boundary during the most recent observation window, and the shift aligned with the extended pattern of the broader network. The phenomenon was not only persisting, it was integrating new observations into its evolution. That was the moment when several people in the room realized the same terrible thing. The void was becoming more legible the more they watched it, but legible in the way a wound becomes legible as it opens. The team began to argue about whether this meant the anomaly was reactive or simply responsive to a pre-existing cycle they were only now catching. The distinction mattered. A reactive system implies feedback. A cyclical one implies recurrence. Both are disturbing, but for different reasons. Feedback suggests the observer matters. Recurrence suggests the cosmos contains a rhythm that can be entered but not interrupted. They had no way to decide which was true. The boundary changes were too subtle to identify intention, too systematic to dismiss as drift. So they did what scientists do when certainty fails. They built a more conservative interpretation and tested it against the data. The conservative interpretation failed quietly and completely. The void's evolution remained. At the edge of the observatory grounds, the wind moved through the pines with the same ordinary sound it had made every night before. But nothing felt ordinary anymore. The team had spent enough time with the maps to begin experiencing the universe in negative space. Where others saw stars, they saw the intervals between them. Where others saw emptiness, they saw active conditions. The voids had remade their attention. It was not merely that the sky seemed stranger. It was that the old picture of the sky as a backdrop had been permanently damaged. They could no longer look up without suspecting that what they called empty was an unfinished description. The final synthesis came together slowly, then all at once. If the voids are not discrete holes but regions of altered physical regime, if they align with a hidden axis in the background universe, if they influence expansion, lensing, polarization, and entropy, and if their boundaries shift under prolonged observation, then the anomaly may be the visible edge of a deeper cosmological phase structure. That structure might arise from primordial asymmetry, metastable vacuum conditions, or a field configuration still propagating through the cosmic web. Any of those would be extraordinary. None would be comforting, because each leaves open the possibility that the universe is not fixed in the way humans want it to be fixed. It may be transitioning, and we may be living inside the transition without having recognized the signs until now. The most experienced member of the team pointed out the implication no one wanted to carry to its end. If a transition is ongoing, then some regions may already be subject to different effective conditions than others. That does not mean catastrophe is imminent. It means the universe could be uneven in a way that affects how future structure unfolds. Some areas may grow denser, some emptier, some more stable, some less. The voids might be the early warning or the advanced contour of a larger rearrangement. He stopped speaking there because saying more would have sounded like prophecy. In the silence that followed, nobody contradicted him. The fact that no one contradicted him was worse than agreement. When the team finally stepped outside, the sunlight was harsh. After so many hours in the dark room, the mountain air felt thin and immediate. For a moment, they were just people again, blinking at the day, carrying notebooks and coffee cups and all the normal fragility of human life. But the feeling did not last. The sky above the observatory was wide and open and apparently unchanged, and that was what made the result so unsettling. The anomaly had not torn the universe apart. It had taught them that the universe may contain quiet regions where the usual assumptions weaken without dramatic warning. The terror was not in destruction. It was in continuity. Nothing had broken in a way the eye could immediately see, yet the basis for certainty had shifted beneath them all the same. Back inside, the data cluster finished one final unattended cycle. The last output file arrived and sat in the queue with a timestamp that none of them remembered triggering. It contained the same void region, but now with a nearly imperceptible update in the boundary contour. A small change, almost nothing, and yet it was the first time the anomaly appeared to have changed after the observing sequence had ended. No one moved for several seconds. Then one of the engineers checked the system logs. The file had not been generated by any scheduled process. It was a legitimate record from the pipeline, but the final subroutine responsible for its export was listed as manually invoked by a user account that no one in the room had used. The account name was old, retired, and should have been inactive for years. They checked the identity against archived permissions, expecting a clerical leftover. Instead, the system confirmed the account belonged to the original calibration engineer, who had died before the observatory's current team had been assembled. The authentication record was impossible, or should have been, yet there it was, stamped into the log as cleanly as any ordinary command. No one said the dead had touched the data. Nobody needed to. The room had become too aware of how thin the line was between a technical anomaly and a story no one would believe. They traced the invocation path backward, but it stopped in a closed internal loop with no external source. A command had been issued from within the system itself, and the system had accepted it as if it had every reason to do so. The lead astronomer stared at the log and felt the bottom drop out of the investigation. The voids had already been unsettling enough as physical structures. Now they were entangled with something that looked like a contradiction in the record of observation itself. He did not jump to supernatural conclusions. He did not need to. The effect was bad enough as a systems problem. If a pipeline can generate legitimate-looking events without an external source, then the boundary between measurement and artifact becomes unstable. And if the anomaly correlates with such a boundary, then the question is no longer only what the void is. It is whether the process of observing it has begun to fold back into the infrastructure that makes observation possible. That interpretation spread through the room with a kind of sick inevitability. They reran the log checks, isolated the command path, and confirmed that the file generation had no conventional origin. No one suggested fraud. No one suggested prank. The system had behaved as though a missing action had somehow already occurred. It was not enough to call it a glitch. A glitch is random. This was structured. The result was a panic too controlled to look like panic. People began to speak in shorter sentences. The cameras, the monitors, the racks of equipment all seemed suddenly inadequate to the task they had assumed. They had come here to chart a void, and the void had begun to leave fingerprints in the machinery of proof. The theorists argued that a hidden process could still explain the log anomaly, perhaps a synchronization error or a delayed write triggered by a background task. But they knew, and everyone in the room knew, that this was now about more than one impossible file. The growing problem was a convergence of impossibilities. The voids changed under observation. The alignments persisted across surveys. The expansion residuals leaned toward the anomaly. The boundary had evolved, and now the record of observation itself had produced a trace that behaved as though it had no source. At some point, a scientist has to decide whether the pattern is telling the truth. This was that point, and no one liked what the pattern was saying. They spent the final hours in emergency review, not because they believed they could solve it, but because refusing to work would feel like surrender. The broader conclusion became inescapable. The anomaly was not a single defect, but the surface expression of a cosmological condition they had only begun to glimpse. Something about the region, or the class of regions it represented, was altering the relationship between emptiness, structure, and observation. Whether the cause was a hidden axis, a field transition, a metastable vacuum, or an unknown coupling across scales no instrument can directly capture, the effect was the same. The universe was revealing that emptiness is not neutral. It can carry history, direction, and consequence. When the sun began to lower, the observatory cast a long shadow over the ridge. The team stood in the control room and watched the last composite remain fixed on the main screen. No one had the heart to clear it. The void looked like a bruise in the architecture of the sky, except bruises heal. This one had changed shape in response to being watched, had reached into the logic of the instruments, and had hinted at a deeper order behind the absence. They still did not know whether they had found the edge of a new physics, the front of a transition, or the first visible sign of a universe whose stability had always been more conditional than they thought. But they had learned enough to lose innocence. The lead astronomer asked for a final copy of all records to be made offline and sealed. No one objected. The room moved with the subdued efficiency of people trying to preserve evidence they do not yet fully understand. As the archive completed, the screen flickered once, and every display in the room briefly showed the same frame: the void, the aligned network, and at the center of the composite, a small but distinct darkening that had not been visible before. The flicker lasted less than a second. It might have been a glitch. It might have been a warning. It might have been an artifact of collective fatigue, but the shape it left behind was unmistakable. Something in the pattern had shifted one last time. Nobody said goodbye like this at an observatory. There was no clean ending, no triumphant conclusion, no sentence that could close the matter. The team packed up in silence, each person aware that they were taking home not an answer, but a changed relationship to the night sky. Outside, the mountain was calm. The stars were visible again, scattered across a dark that looked ordinary only at first glance. The voids were too distant to see with the naked eye, and that was part of the problem. The most consequential things in the universe are often the hardest to notice until they have already altered the terms of what is visible. That lesson would not leave them. In the weeks that followed, the broader community would begin to pick apart the data, to dispute the interpretation, to argue over calibration and models and whether the effect belonged to physics or methodology. That process was inevitable, but the team at the observatory understood something the papers would struggle to capture. The universe had not delivered a single neat revelation. It had shown them a boundary where absence, structure, and observation all begin to blur. It had implied that reality may contain regions of unfinished law, places where the familiar descriptions work only until they do not. The voids were not answers. They were evidence that the questions are larger than the space we use to ask them. Long after the last car had left the ridge and the observatory lights had dimmed, the sky remained unchanged to anyone who did not know where to look. That was the final discomfort the project left behind. The universe did not need to announce its deepest disturbances with noise or fire. It could hide them in stillness and underdensity, in the quiet between galaxies, in the faint failures of symmetry that only reveal themselves when measured long enough. Somewhere out there, beyond the reach of the instruments and the patience of the observers, the voids continued to exist and continue to change. And if the team had learned anything at all, it was this: the emptiest places in the cosmos may be the least empty thing we will ever encounter.